comparatively 15% less. This is what my observation. This is what I saw. So
Hmm.
I'll keep it. I'll keep very close eye next maybe a couple of months as well, and then I'll be in a, then I would definitely share my experience that whether this is right, whether this is a correct observation or not. So
Hmm.
that is something that
That's
I
important.
observed during this week.
Yeah, your observation, I also agree. That all comes under the context window management or context management, right? So we need to do a lot of, after understanding the rack today, in future we do have cache augmented generation, even the tokens, you were just talking on the tokens thing, right? So even within your window also, there may be some things in a cache I will try to push it so that that's not tokens being consumed only once it is there, but only the incremental thing will go, right? So like that, once you understand some of these terminology in a little more details, you can add more context engineering to that, right? And then observation point of it, I am with you. And then how do you address that? I'll give you some tips, and then you can also see how it is really working. Okay, perfect. So then let's slowly go into today's session. Let me tell you a brief in terms of maybe for a minute, where are we in the journey, right? So if you see our journey, so we just started with our introduction to Gen AI, then went into the application space, understanding the engineering part in the third session. The fourth session, we went into the deep dive of these mm, uh, what we call the prompt engineering to some extent. Are we able to cover the parameter efficient fine tuning as well? Last week only, right? We covered prompt thing till the end. PFT have you covered or?
Don't think so,
I don't
person.
think, right? So we did not have time for that. Yeah, we will cover that. No issues on that, right? So there is a React thing which you are asking. I'll cover, but let me go with the flow first, and then maybe during the break or once I complete it or towards the end, I'll try to cover that. That's a specific thing. So now, if you see with the agenda, we start with vector databases. Then what is really the retrieval augmented generation? What are the different types? We have simple, then I've given some of the pre-reads also, if at all you want to go through last week deck. Then implementing the rack-based system, how you want to, we will show you some screenshots of implementation, and then actual implementation you will also do in the Azure a week later, right? So then orchestration with example is what I am showing it to you. So here today's key takeaways will be in understanding why we need a separate vector database. After understanding the typical databases, then comes the details of each of the term. We'll understand what is retrieval, what is augmentation, what is generation, how are you measuring the success of each of them, what is the end-to-end flow when it comes to the prompting. So the overall flow as of now is okay. There is a LLM, I'm giving a prompt, I'm getting a response from LLM. It is as simple as that. If you are double clicking that, maybe I'm converting it into a text embedding and then pushing it to LLM, getting that. Now, how are you changing that entire architecture with the rack-based systems is what we will be understanding today. If you go further on that, so before we see the traditional databases, how it is different for vector databases, let's understand this part. So we do have different types of data. If you recollect structured, unstructured, 7 types of data is what we have. Numerical, categorical, text, image, audio, video, signals, all of that what we started with. They're in what form? Maybe some image form, documents form. Okay. So when you push that data, if you are storing directly, maybe some data lake is good enough. If you are extracting some information from there and pushing, maybe data warehouse may be a good choice. But now I am not trying to store it in that form. I am trying to store in a vector form right now. What does that mean is we are trying to create some vector embeddings and then we are able to have some embedding model. So Titan embeddings, what you have as an example, then we will try to see what kind of embeddings will help us to get it into creating those embeddings. Once, do we need to define that? No, just like a typical model, what you see OpenAI or any of these, we are trying to uh, have a standard methods, right? It's not like hundreds of models are available, maybe some tens, right? So it is maybe inspired by your word-to-vec kind of a knowledge. Then we will have those embeddings, that vectors will be stored in a vector database, and we will try to understand why we are storing in a vector form. Why can't we store in a regular standard form only? The point is, when you try to compare semantically, getting that relevant information is much faster. Okay, in vector database. That's the reason in the recent world, especially from Gen AI thing, when you are giving some response within few milliseconds, right? So getting to a data lake, getting that processed and all that is going to be very time consuming. Okay. But if you have directly SQL, NoSQL or a processed data, yes, we do have both the things. Just think of it in practical sense. We have DB search, database search, and doc search, which we implemented in production in my previous organization as well. It is very common in your organizations. You want to retrieve some chatbot, get some information in your enterprise level. The very common thing is having both the paths. The one what I'm concentrating now is the path of document search, document or image, any of them, video, audio, how I can use it in the embeddings and push it to vector database and get that. But if you already have some information in a table format, okay, not in this unstructured format, in a structured format in a table, then I'm not again converting that into vector as a general practice. Instead, we are trying to convert your natural language into an SQL format and get that information. Sometimes we may be able to fetch both the information. Here, the similarity of the vectors is giving me some information of vectors. Some from text to SQL, what you converted is giving me information. Maybe both of them also I need to send to the LLM to final answer. So that's the practical scenario. Are you able to visualize what I'm saying in practice?
Yes, Professor. And the embedding will not be for the entire paragraph. It will be for each token. Is that correct?
Yes, that is the internal details in terms of how embeddings are going chunking, then tokenization, right? Those details also. Then what your point is, correct. It's not like, I mean, it is processed entire document or a paragraph, but how, at what level it is taking that embedding is at a token level. Yes.
Because the reason why I was asking is in some of the books, they show that it is one array of 768 instead of
Yes.
independent. So that's why I was
No, no,
getting.
there, yeah. So I understand your confusion as well. Only thing is, yes, at a vector can be at a word level, token level, or you want, just like you remember earlier, there is a word to vec, doc to vec, sentence to vec before this embeddings. I'm talking about maybe 10 years ago also, when the vector vec. So have you heard those terms
Yes.
in a traditional NLP? So there also, we can have one vector to a convert to embedding, or one sentence you can take and then try to get it into embedding thing, or you can go into the doc to vec. But more famous one is word to vec. Similarly here also, you have option to play with that because it in terms of how much of overall context you take into consideration, then the embedding value may change the patterns of embeddings, but ultimately you are giving it a token level, right? But the variations may be there in terms of getting it into a little one more level of upper hierarchy also. We can take specific examples and I can show it to you.
So
Sure.
from
Okay.
Professor,
Yeah.
so what I got from this is that the best way it's best to transform to vector, but it also can be transformed to SQL, right?
Not this one. So I think you are mixing two things. If it is a image, documents, video, audio, my preference is to go to vector, as I show you in the picture.
Uh-huh.
But if I show you the other one here, if you have something on the leave the vector database, sorry. If you see the other ones, where is this? Yeah. So if you see it, there are traditional databases also which are structured data you are storing, optimized for transactional data. If you already have that, I am not trying to push entire thing to your vector database. Instead, I will have some text to SQL that LLM can do and get that information also. Sometimes I need to have both the information. I'll tell you one example. In an enterprise setup, what are the top projects bleeding, or maybe it may be a little more formal, I can say, what are the top 10 projects this week which needs the CEO attention or CFO attention. If I want that one, do you go to traditional databases where you expect your data to be, or you will go to some kind of vector database? Just think of it, or both.
Maybe both.
Okay.
Sorry, I didn't get the questions.
Question is very simple. Let's say in your organization you implemented both. You have some tabular form capturing your regular data of the projects. You are creating these vector databases, just following your images, documents, and all not in the raw form. You convert it into vector database. Now in the practice, I'm asking one question: what are the top 10 projects which needs CEO attention? That means what the CEO attention? Maybe you can ask one more question saying that you are asking positively or negatively. That means what? If everything is good, he can clap for it. But let's say, let me little more specific. Top 10 projects which are in red, which needs, let's say, the CEO attention. If I give that as a prompt, where you are expecting the data to come from? Is it coming from vector database? Is it coming from traditional database?
Well,
Possibility.
usually they put it in traditional, right? But
Exactly.
it's better if we do vector, right?
Depends. Vector means I am not creating for my answer, right? So just think of it.
Okay.
Just think of it. If I have some document or image or video contains that, then I am using vector database as a form for me. If already traditionally you are maintaining your databases, which you have this is the total budget, this is what the flags, this is what maybe some mails or maybe some summary reports if you have, those you will push it to vector database for your summary. I don't have a problem. But if you're already capturing some of these, what are the top 10 projects which are in a negative, I can get it from a database directly, right? If some more information you require, you go to vector, I don't have a problem, right? So let's see inputs from Prince. Yeah.
So,
Prince, go
yeah,
ahead.
it all kind of tell that I'm story. If it is heterogeneous in terms of the format and how it actually look like image, documents, and video, then definitely it will be vector databases.
Yes.
If I have structure or semi-structure, then it will be my traditional database because getting a top 10 out of it, traditional databases are better.
Yes. Exactly. So that's what I'm trying to tell you. And then we can go a little further because you are started understanding the engineering and then entire the structure, right? So next few sessions, once I complete these basics, then I'll go a little more further in terms of architecture, in terms of this. Even now also I can speak because I given you the bigger picture last time. What we are talking there is we can understand even the user intent based on the questions. It can be a rule-based system, it can be an LLM-based system. So based on the type of question, I can choose either traditional database, I will go push the query, or the vector databases, or both. Sometimes it is based, that is comes under the optimization. Sometimes I don't require to go both. If I know very clearly the data will be there in traditional, but yeah, let me query that and get back, right? So similarly, some data is very clear. So there is if I ask, what is an employee policy for your optional holiday? Where do you go? You go to traditional database or vector database?
You have to go to the vector database because
Exactly, because that is there in the policy document. That is not traditionally structured way it is stored. So then naturally you will go into that. Some places it is clear from user intent. Then I'll just don't burn my energy in getting into SQL. I'll reduce the number of LLM calls, right? So if it is a doubt, better go with both and get that. That's not a problem. But you can understand user intent and improve that over the time. Okay. So yeah, you have Suvir. Any question, comment?
So I have a question. For those who come from a non-technical background, before you jump into how vector databases work, is it okay if you spend a couple of minutes on just explaining the fundamentals of what a vector database is first?
Yeah. Yeah. So this is where the vector database in terms of the fundamental things are this slide only. We are storing the vector embedding, that means the vector form, and it is in a multi-dimensional space, and it is optimized for AI and machine learning. And the way you are searching, just like you are searching in your traditional databases based on the queries. So here you are trying to search by the similarity search, and I'm going deep dive into that. So these are still one level. I still have 2-3 more slides to explain to you. We'll do that. Jansi?
Thanks.
Yes, Professor. So maybe I take your example like I also thinking in the example of my SAP context, but I'll take your example which you mentioned about if you have a organization policy and then we try to identify your leave, vacation. So connecting that, then we said we are going to use vector database because if I use a simple SQL query, system will say like, okay, I don't have corresponding information. So until unless if you write multiple join
Yeah,
queries.
there's a
So
complex there.
maybe my question is like now you take leave policy is easy, but my I'm working from SAP. So in my case, if I have a functional specification, so I want to write a query says that okay, how do I approve my urgent change document? What's the functional specification process or change management process for the urgent change? Okay,
Mhm.
in that case, how can I tell the system, okay, please use the traditional database or use the vector database? Is something like I have to decide with my
No,
knowledge? Okay,
it depends. It depends on the maturity of it.
okay.
So if you want to put in a prompt and then direct it, then you do it. No problem on that, right? But every time the user, you have knowledge of it and you are asking, but I can't make that as a standard thing, right? So if it is, if you're just asking your prompt, it is the duty of the underlying system to take care of it. If you are giving explicitly on top of it, no, I want to go with the traditional route. You want to prompt, put it into the prompt, yeah, please, nobody stops you, right? That means you are utilizing your domain knowledge to make sure they were optimizing the prompts and getting the quick latency response in the quick latency, right? So that is perfectly fine. But while you are generalizing the system, I am not going to expect everybody will do at that level.
So if you have a traditional database as well as vector database together as a knowledge base,
Depends.
and this is
Yeah, as a knowledge base, we need to have. Some places we may, while starting, to be frank, I have only vector database to go ahead because that's where we are starting with, right?
understood.
Most of the organization. But the next level, at least at enterprise level, I will have access to both.
Both are
And then initially, if you ask me, people will get confused, right? So first they will start with vector database, all the documents, unstructured data, let's push it, let's use it. Then you go into because what I'm talking now, the same chatbots can be your companion agents down the line. Right. So what does that mean? It's the general terms. What I'm using is very general, nothing proprietary and all. So within that chart can be your chart co-pilot, or it can become an agent. That means you are controlling some of the actions in there. When you are talking at that level, what happens is you need to have control of most of these things and how it is working. Then only you will be able to go to that level. Okay.
got it, Professor. Thank you.
Yeah.
Yeah.
Prince, you have another
So
question?
I'm sharing one of the use case which we have recently started as a pilot project into our organization, where we have started thinking that to utilize the vector databases. And why so? Because recently we have seen the performances of our products. It actually based on the sentiment of our investors, and this can be influenced by the different medias as well. Like what are the images that they are putting, what are the discussion they have into podcasts, and such kind of data cannot be stored into our traditional databases. That's why we thought to have a kind of database which actually gives us this gist of the overall conversation happening in the podcast, or the images and the sentiment on the different social media websites. So those kind of stuff, we think that vector database would be best to put us into a position where we can analyze and find out what is going wrong, what is the view of the people, and that's where we can come up with something that can help us to improve the performance of our products. We're on mute, sir, I guess.
So what I'm saying is, yeah, it's perfectly fine to think of those and then for your analysis. Only thing is, sometimes the RAG-based systems start with the enterprise within the applications. In your case, you may be depending on the external data sources as well, and then how are you bringing that into your company information, or maybe company external executives talking on the external sources, or people are talking about it, right? So that's perfectly fine. So this is related, and then you are bringing on the table. Okay. So, Jens, you covered, or you still have one more before I close? Your hand is still up. Okay.
Sorry, Professor. Please proceed. Yeah.
Yeah. So now, as some of you are asking, let's go a little more detail because some of you understand what is vector database. Some of you may be hearing for the first time. We need to do justice for both, right? So before jumping there, I'm trying to tell you there are so many different types of databases where key value pair beyond your RDBMS thing, right? NoSQL. So if you ask me, there is a RDBMS is where everybody may be familiar with Oracle as an example. Then NoSQL kind of a database also may be there in terms of storing the document. Then you can challenge me back. If I can store a document in a NoSQL, why do I need to have a vector database? Right. So the point I can emphasize there is they are not optimized for AI or machine learning, as you have seen in the previous slide. So just from a storage perspective, RDBMS is not the option. So then we go with NoSQL is okay. But for us, when you go into little more details down the line, so the documents are all good for a typical NoSQL. But if you are really trying to see keeping the latency, keeping the similarity search of how it is working, it is good to have some kind of vector databases, right? So that's what we are talking about. In summary, as you see in the top, as some of you are asking, it is the similarity search engines or approximate nearest neighbor search engines, specialized databases designed to handle high dimensional vectors efficiently. So that's the definition I am talking about. They provide capability to quickly retrieve most similar vectors. Is it perfect every time? No, may not be, right? But it is giving to give you high dimensional space for us to store. And what you can see here is similar to what is your what to vec. Is it fresh in your mind, your what to vec? Maybe learned in previous sessions.
Yes.
Similarly, you can visualize this. I will give you some more explanation so that you will be able to appreciate that. But the basics will be helpful for you to think at that direction. So there are like Pinecone DB, ChromaDB, and all that, which are very specific. Or some places even Oracle kind of a thing is supporting even the vector databases also in a different form. So when you go a little more details into that, what is really happening, and I will tell you how do you choose when you have so many options like this? What does that mean? Some are pure vector databases. I have shown it to you, like ChromaDB, Pinecone, and all. Then some are search databases, text search database like Elasticsearch or Lucene and all, Open Search. But they also can support. Similarly, vector capable NoSQL database also there, like Neo4j is for good for graph database, Cassandra is there, MongoDB is there. They are also trying to support the vectors, storaging of the vectors instead of directly the SQL thing. Similarly, vector library, just as a pure vector libraries like FIS, or maybe vector capable SQL databases, right? Like your PG vector, Postgres, single store. So these are all these are traditional bases, but they are still getting these support for this vector. So when you have these many choices, my next question will be in terms of where are we here? Then yeah, my next question is how long they are around. So let me tell you some inputs. If you want to add few more on top of it, let's discuss and then agree on. These are the 5-6 points or even 10 points to decide which one to take. One is how long they have been around. That means why that is giving you in terms of 2017 onward they are. So the older they are, maybe some impression that more users are there, but depends on who is funding also makes sense. The reason is sometimes it is just a university supported, maybe 10 years old, but you are not getting enough support of the funding, then it may not survive long. That's what I can give you another analogy to you. If I ask you what are the deep learning frameworks you are familiar with, what is your answer? From your deep learning knowledge, what are the top 2, top 5, whatever, how many ever you can recollect? Top 2, top 3. The deep learning frameworks, because the deep learning is covered already, you are already familiar, so you should be able to tell.
You were asking about CNN.
No, they are not the frameworks. I'm talking about tools, frameworks for the deep learning. Just because I'm talking about all these ChromaDB, Pinecone from a tools perspective, right? Similarly, for deep learning, there are
TensorFlow and
exactly,
TensorFlow.
exactly. TensorFlow and
Scikit-learn is something that
scikit-learn is more from a machine learning.
machine learning, and
For my
TensorFlow is
deep-
something that we use very often.
Exactly, TensorFlow and PyTorch, if you heard of, right? So these are the two top ones in the market now. But if I remember 10 years ago, when I'm not even, now we are in 2026, right? Yeah, at least 7, 8 years ago in different keynotes, I used to tell Why do we require a deep learning framework? That I'm not talking anymore because everybody's convinced now, right? But there, I still remember similar slide like this. We have something like that time even PyTorch is not there. Torch is there, right? Not Python based. The Torch, TensorFlow is slowly coming. It's not the leader at that time. Then we do have Caffe, CAFFE, Caffe. Then Theano, THUONO. Then like that, there are multiple frameworks which are available, and we used to tell the same thing here while choosing because initially they are all supported by Cafe Sustain for some time because it's supported by Facebook. Otherwise, Theano and those kind of frameworks which are supported by the universities, they could not sustain long. So that's the reason how much of funding is required. And if they are big giants like the Facebook finally went into the lessons from Cafe, then get it into the Python penetration. They convert it into PyTorch. Now you don't require to worry about the legacy. Now it is more of PyTorch or TensorFlow is the top ones. So that's the reason while you are choosing it, you need to understand even the how much of funding, who has funding, who is supporting is also important. So then whether it is open source, closed source, is that available for you to play with? What is the cost of it? What is the preferred language, program languages they are supporting? Is it can be managed, self-managed, and then cloud native? How the indexing methods are used? These are at least some 5, 6 top methods, top tips, I'll say, while choosing the best one. Out of these, typically, you can say, after doing all this also, my recommendation next is go to the leaderboard. If you just go to the leaderboard, what are the top 5? Okay, so maybe somewhere down the line, I may present one slide as well. Top 5 or top 10. From that list, what is ask these kind of questions, which is maybe another question I can see is I can talk about as a if I miss any of them, please, whatever is coming to your mind, but a few more are the cost definitely. Beyond the costing, another thing is in terms of, I was thinking of one more integration aspects. So this thing is how easy for you. Suppose there is most of the people are using ChromaDB for one particular tech stack versus the other, then you will also get okay. All of them are in top 5 list. They will get the support for your environment. What kind of integration you can think of? So that's the next part. So anything else I can think of beyond these? Let's say top 10. What we are talking here. So I do have 1, 2, 3, 4, 5, 6, okay, 7, 8. Okay. Any other things comes to your mind? Maybe in chat you are mentioning it. Yeah, MXNet from Microsoft. Yeah. Nimish, old ones. Yes. Production support, right? Yes. The support what you require as well. How much support directly, indirectly we are talking about, but we can talk about the production support. Yeah. Have we covered all the background? Anything else you can think of? Okay, good. So yeah,
cybersecurity and scalability, I'm not sure.
exactly. So that's what the next thing is scalability, security. Yeah, important point. Because this is the security and privacy also, whether they are. So sometimes what happens, you need to be compliant. So these databases needs to be compliant to store specific customer data in a regulatory domain. So those standards will be there. That also important from a security and privacy thing. Yeah, good. So we're able to cover a lot of ground there. Then if you go further on that, before I go into the RAG, one more or 2 more slides just to summarize. So maybe Elastic or Pinecone, Chroma. So you can see what is the type of it, whether self open source. Then can you do some of them are pure ChromaDB kind of a thing is pure vector database. Some of them are started as an extension. They are already there, and then they are extending it. So similarly, what is the SDK they support, right? That means the Python, Java, and all support for both stream and batch data. Some of these also comes into picture while you are deciding it, right? So just like we have analyzed, you can take inputs from some of these, which can help you out in terms of whether they're specially built, what kind of integration, and then can they be consistent, and then support for both stream and vector. That's also important. Whether it is supporting the stream data or batch. Mostly we may see both as well, but it needs some of them may not be supporting that, right? So that's where the scalability thing also comes into picture.
And these frameworks have a binding over PyTorch or TensorFlow, right? One of them. Is that correct?
Depends. Mostly that is because this one is more of a storing these vectors, right? So on top of it, how we want to extract it, because it's mostly there's a similarity such as what we are giving, right? So it doesn't have any direct dependency on the framework, but they can collocate.
Most of the computer vision frameworks are TensorFlow dependent, and most of the NLP frameworks are PyTorch dependent. Is that understanding correct, Professor?
I can say, but may not be generalized that level. But yes, that's where the progress is happening like that. But some of the computer vision in the recent one, because there is also CAFE used to be the leader there earlier before the that, but they have a good. The one difference is that TensorFlow versus PyTorch, you can do the dynamic graph in the these PyTorch, but slowly the TensorFlow also in the recent version they are able to get that too. Initially, it is not, right? But it depends on you are talking mainly on the usage perspective. Both of them are equally capable from technical capability. There is no difference. But many of the things you see from implementation, open source implementations and all. But some of the universities I know, they are hooked to only PyTorch, right? So some of them will give there. So, but from computer vision or NLP, yeah, maybe you may get little more examples of TensorFlow, but PyTorch is also equally good.
Now, I see here the SDK line, it only calls for Python and Java,
Yeah.
and which means that it is independent of TensorFlow or PyTorch. Is that understanding?
It's independent, yes.
Okay, thanks, Professor.
So just to summarize those points in this particular thing, first, how are we going on the time? Yeah, we are good. So because this is important for us before I directly jump into the rack, we need to understand where are we storing, right? So that's why we spent at least 30, 40 minutes on this. Then here, just to make sure before we go into the retrieval augmented generation, how they are fitting it into. So the vector databases, what you are seeing internal, that is their internal, the replications and all. We don't require to double click on that further, but at the same time, it is easy for us to understand when an application level, when I give some top K results, give it to me in a semantic way. It goes to load balancer and it will directly query engine. If I simplify this, yes, it goes to one simple, the entire box I'll say, I'm asking some application top K results, it goes and then give me in a similarity search. That's the one line going and coming back. But internally, if you see, there is a load balancer, there is a vector indexing, and then how you are doing the storage layer with the replication, because you need to take care of a typical database, right? So that's where we are able to give you little more details of it. But ultimately, what is important is there is an embedding model directly when you are getting the results you may get here. But ultimately, you are pushing it to an embedding model. Sorry. Some Titan embeddings. What are the embeddings which your tech stack is supporting? That query embedding you will push and then go to this vector database, get that semantic results, and then push it to the top K ones. To get that one, this is the one-time data. The data needs to be embedded model, and then somebody need to store, right? That's the reason this data is coming into picture. So I'll try to paint a picture in a full Azure or AWS kind of architecture as well down the line. So if you are good so far, I think you asked enough questions as well. So if you have other questions, let me know. Otherwise, slowly I'll connect the dots in terms of what is retrieval augmented generation here. Okay. So are we good to go?
Yes, Professor.
Perfect. So hope the pace is okay for the people who don't have background as well. So hope you are able to follow. And main importantly, why that is important. What is that is one anyway we are covering. Beyond that, why and how it will impact the overall thing is also what we are trying to talk about. So first, let me tell you before going into the slides and all that, what is really the RAG is. So there are different types of RAG and all that. So in especially in enterprise setup, we do have the powerful LLMs which you are accessing through, right? We do have already when you talk about whether it is OpenAI, whether it is Copilots, or maybe the cloud models, you have access to your own based on your tech stack, based on your collaborations, partnerships, and all. You are able to get that particular based on the tech stack what you are talking about. You are able to get to a situation where this is where the LLMs you have access to. But the point we are trying to emphasize here is if the knowledge is already there within the LLM, you are just talking about the prompting, then I don't require a RAG kind of a system. But why we need a RAG-based system with whatever the information which you have last time, maybe some external knowledge plus the internal one and all that, the prompting can give you the good set of information. That's perfectly fine, right? But the next step is in terms of getting that into, let's talk the real need, right? The enterprise information, your data, then your documents, then policy documents, or maybe your MOUs, memorandum of understanding, that is not a public data at all, right? This is confidential information. So if you are very strict in terms of a defense mode or regulatory mode, they are not even believing your these LLMs as well. They are starting from scratch. That is one extreme, right? They are starting locally from scratch, or maybe they can use some of the open source models like Llama if they really want to, depending on the severity of the privacy aspects. So then when we go to the next level, especially when you are talking about enterprise data, they need to get the information, what we need to give it as a context. What does that mean? You may argue, I will go with the prompting, whatever the 10, 5, 10 documents, I'll just go and upload in a local context. Good enough. Even that is also solving my problem. Yes. But that is not a persistent way of doing it. If it is only 1, 2 document, 10 documents within a limit, within your context limit, you do it. No issues on that, right? That means you are giving external information. So just like your other design patterns, right? So just like your chain of thought, React and all, you are trying to get some external information also beyond what the LLM knows. That is perfectly fine. But those things, to make it into a consistent way, we are proposing some method like retrieval augmented generation. What does that mean? Just as an example, before I go into these architectures and examples, I'm asking simple leave policy or maybe some enterprise who are all the customers we are engaging with, right? That information for a general LLM may not be able to give me the potential customers, all that. Then that particular information what you have from your documents or maybe some video forms and all, somebody need to push it into a vector form, just like we have shown it to you vector database. That's a one-time effort. After that, based on my query, whatever I'm asking, right? So based on my query, what it is telling is we will be able to convert it into also vector. It needs to be apple to apple comparison. The vectors when I'm trying to search by the similarity, the query also need to be converted in that vector form, same embedding I need to be using. Both of them will be comparing in a simple semantic search. Okay, there are other variations. That's okay. The simple semantic search, the similarity search, right? The semantic layer will come little later and all, but the similarity search, that means what? The cosine similarity is what they are measuring with, and able to give me some vectors which are matching with that. That vectors also will go along with the query to the LLM before we get the generation. So there are two parts. Retrieval. I am retrieving the relevant information from vector database. I am augmenting that along with the other vectors before I send to the LLM, and I am getting a generation output from the LLM. This is in simple words what is really happening. But I'll be able to double click for you in terms of in the text or maybe some pictures. What is the simple way of doing it? What is the advanced way? What is the modular way? We will go into the details. So this is what I'm talking about is a simple RAG, a naive RAG, a plain vanilla version of it. But we need to have a little more details in terms of how do you go into advanced one? How do you, sometimes that particular text what you are giving or the prompt what you are giving may not be good enough. I need to optimize it further. I need to enhance it further. So those things comes under the next step. to understand that little further. So as I mentioned, specific knowledge may not be able to go there, or the context is missing. That's what I am giving here as a backdrop. Then one more thing is the personalized answers to get. Definitely a RAG-based system is good. Then teaching the model to recognize when it does not know, that also is important for us. Okay. So in a RAG-based system, what happens is you are asking the model to respond to a question by browsing through the content in a book. That means I am giving it to you a specific vectors, as opposed to trying to remember the facts from memory. Okay, that where we are trying to tell here, saying that you are having extra hand holding of some more information which may be more relevant. Which one you want to give priority? If you have a conflict thinking, that depends on the context. If you want to give more priority in general, can be for your enterprise level. But some questions, if the policy related and all, maybe you need to give priority to the uh, outside thing as well. Okay. So when you are talking about that type of RAG, let me go into naive, advanced, and modular. Once I go into those details, so these are the points which you will take. Right. First, let's understand whatever I'm telling you in air. Some of you may be getting it. Some of you may be still understanding. This structure will help you out what we are talking so far. Okay. Before going into the naive, advanced, and all that, let's understand the basic RAG. Okay. You are as a user asking an input. Let's say the situation here is maybe Sam Altman, if you recollect, an year ago, he was sacked from from the position, from the board. There's the disputes, all that, right? So then, when you're asking some query like that, if I'm directly giving to an LLM, maybe I'm not getting that information because that LLM is not trained like every day, right? Unable to provide comments on the future events, all that. So, but you need to have something you remember. Some of you are talking about, I will use some kind of a React kind of a pattern. Maybe if the LLM is not directly giving, let me go and externally fetch that information and go. That is also possible. Okay. So that you will get some answer. But if you are talking about anything specific where this documents, indexing, chunking vectors, all that is already available, this query is being converted into that embeddings. We are able to search the relevant embeddings and then retrieve some chunks from the relevant documents. Those chunks are also combined with the context as a context and the prompts. So you are combining the prompt along with this chunks, what is being retrieved. That information is pushed to LLM. That information is pushed to LLM. Then LLM is giving you the answer in a little more personalized way to this information. Okay. So this is what the basic flow. And then before I take to the advanced one, everybody needs to be good, whether you are using it or very completely new for this flow should be clear to you. Then we'll go into where do I extend it. Go ahead.
Professor, a few questions on this.
Yeah.
And so initially, based upon the data, like the lower orange with the RAG, right?
Mhm.
And there are few questions are fed during the time of generation. This even before the user query. Is that correct? This is some kind of a semantic information gathering that way, or okay, it is coming from the indexing part. Okay, the documents get indexed, it creates chunks and embeddings. Now the embeddings are associated with the chunks.
Yes.
And the chunks are basically semantic chunks. Like somebody parses that where the semantic switches over, so that way the chunk will have a semantic boundary. Is that correct understanding, Professor?
Yes. Yes.
Okay.
So the second one is correct. Yeah.
Yeah, and then that will get stored in the vector DB.
Yes.
And the original document excerpt will not be stored anymore. It will be only chunks and vectors. Right?
Yes. Yes.
Now, when the user is presenting a query and that query get vectorized, and the entire query will be vectorized as a single vector or into again chunked vectors.
That also chunked vectors only.
Chunked vectors.
Yes,
and
because we are comparing with the chunked vectors only. That's why the chunking policy is important. Then these vector, the same embeddings we need to use because it's more like a apple to apple comparison we are trying to do.
So the user query may have around 400 words, which may get converted into 500 tokens,
Yeah.
and that might have logically around 25 to 30 chunks, and those chunks will be presented, and the matched elements will be extracted. Is it correct, Professor?
Yes, you are right.
And then when it is being presented back as an answer, using these vectors, there will be some amount of massaging or smoothing applied over that.
Where you are talking about that smoothing?
Now, for example, the
Getting
user,
that relevant chunks, or which at what stage?
the retrieval chunks, chunk 1, chunk 2, chunk 3,
Top three.
independent or orthogonal, extracts have come.
Yes.
Right now, one talks about returning, and one talks about drama. One talk about the personal angle in
Yes.
in this particular one. Now,
Yes.
when it is being presented, the
Yes.
user will not be presented with these three, and he will be getting one coherent outcome, right?
Yes, this is input to our LLM. So just like a previous information, this is going to an LLM. So it is all abstracted out. So whether we use RAG or not, user doesn't care, right?
Okay.
Whether we are getting the right information or not. If not, what we can have control. That's the only thing.
Okay. So, Professor, even in the RAG model, the LLM stays pristine without the weights altered, and
Yes.
only the external indexing and retrieval that is being
That is the
added.
RAG part.
Okay.
That is the part. That's it.
Thanks.
And some of you are asking for the React as well. In the React, what happens is I am not maintaining this particular indexing, this and all. I may go to a news channel, this and all external sources, getting some relevant information that is fed to the LLM. So that is the relation what I can compare with.
So, which means that somebody is providing that framework which can be added to my LLM.
Exactly. Okay. Yeah, Nimish.
Yeah, Professor, if we can go to, I think, 2 slides back, I think the answer to my question might be yes, but I still wanted to ask
This
that
one?
question.
A picture?
The picture.
Yeah.
So when we say data embeddings, right, what we are saying is that this is the training part of the model?
Yes.
So when data is going to the embedding model and then we get the data embedding, so that is the training part of the model. Is that correct?
You are right. That means you are talking about the training in the sense you are not doing any training of the LLM. I think just be careful. In the training phase means while preparing this vector database.
So this training, so we are always using a pre-trained database.
I think we are mixing. What is the pre-trained database? Pre-trained model, I understand. What is pre-trained database?
So like how would a database have trained information or data embeddings?
What is training in the database?
So like we need to provide some data, right?
Yes.
Then only that database will have a data. So someone
Correct.
has to enter
So
that
it is
data.
not really a model training kind of a thing. Some data we are talking about getting into a chunking strategy, getting into an embedding, and then we are storing those data in this one. There is no training per se.
So how does this data gets generated and how does this database created?
The data is what the data is what you have already in your own policy document. You are not creating for this purpose, but you already have. If you need something which is not there to create, that's perfectly fine. But this is the enterprise data which you already have in a different form and shape.
Oh,
I am trying to utilize that data.
So what we are trying to say here is that database could be like our current policy documents, which are in PDF format.
Exactly,
and all those
PDF,
things.
doc, Excel, all that. Yes.
Okay, so that would be database. Okay, now getting to the RAG slide.
Let me go there.
Yeah. So here, so what would be the case when there is a without RAG situation? We understand the RAG situation, but what would be the case?
But without the RAG is directly, so there is no, this is the line you need to see. If there is a query and you are able to go to a directly LLM and whatever the information it has, assuming that let's say there is no LLM is being trained a month back, 2 months back like that. But if you are using already some React kind of a pattern where if it doesn't know LLM directly, maybe it goes to some external sources and come back, maybe a little better answer may come than this.
So how do we connect this dot? So how do we connect our
Which dot?
query? How do we connect our query, the input
Yes.
query, to
Uh-huh.
the RAG? How
Here,
does that connection
this is
happen?
this is what the connection, what you are seeing here. Ideally, this is the path. If you don't want an LLM, if you don't have RAG, this is the only path. The dotted line, if you can see here, this dotted line, the query is coming directly to LLM and complete it. Whether you are able to answer it or not happy or happy, that is one path. But if you're directly going here, before going to the LLM, you are making sure you are getting some relevant chunks, and then that is also fed to the LLM, and then you are getting the answer. That is the typical RAG path. Query to the retrieved chunks and push it to the LLM, and then get the answer.
I'm still a bit confused, Professor.
Where?
I'm sorry.
Where you
So,
are, no problem. Where you are
like,
confused?
what is RAG? Is it a database or it's a
RAG
it's
is a retrieval
model?
augmented generation, is a technique like prompting, which has three parts. One part is retrieval. The part what you are seeing is the relevant document thing is retrieval. Then second part is that for that one we are using vector database. That's what I have given last 1 hour of discussion. Then augmenting. This I am augmenting in this box the whatever extra information I am getting, combining that context and prompt is augmenting. The generation is the LLM one. So what you are talking, the process is retrieval augmented generation, not like a database. It's not like a what you call, what is the other term you are using. So the point is RAG is a technique, just like prompt. RAG is a technique. To do that, it has 3 steps. Indexing is the first part, retrieve is the second part. Combine it, after that it is a typical LLM only generation.
So how is RAG connected to our current systems? Like we have our own database, we are using LLMs.
Which
So
database?
how does this get?
Which database?
So the database, like we have all our information,
like Oracle database or no,
Yeah.
policy document database is different, and then you are talking about some NoSQL databases or something, or what you were saying database.
So let's talk about our policy documents.
Okay.
So if we have to use RAG to retrieve some information from policy database,
yes,
what would be our steps?
Yes, I already talked about it. If you concentrated that time, I need to first go in, push it to the vector database, just like you are talking about this one. That is the basic thing. I am not doing on the fly this kind of a thing. This is the one which you need to store. Maybe today you have the documents in SharePoint. Maybe today you have maybe in your let's say NoSQL database that doesn't have any connection with the RAG. If you want to use some kind of a RAG, it is your duty to get it into this indexing before I apply for this RAG. Once you do that precursor thing, then I will use the same embeddings to get these chunked vectors, get the relevant chunks, and then augment it and generate. That's what the 3 steps of RAG: retrieval, augmented, generation. That's the technique. It's a simple straightforward.
So first step is to have a vector database.
Vector. That's why we spent 1 hour on that. Yes.
So vector database is also something that we have to
create.
To have.
It's not like training. We need to create that. Yes.
So it's an external model that we have to purchase and we have to create that database.
What is that external model means?
So it's like a software or a tool, right?
Yeah, it's like a ChromaDB or just like your Oracle DB. It may be open source, it may be closed source. Yes, that is a tool.
Okay. I'm getting it. Okay. Yeah. Thank you. Thank you very much. Yeah.
Good. So next.
Professor, I have 3 questions on this slide.
Yes.
Yeah, the first one is could we understand that the chunk vectors is created upon just the log document uploads, and the number of chunks retain the same whenever I keep querying the RAG? That's the first one.
So can you please repeat that? I understand
the chunks vectors.
Yeah, chunk vectors.
The bottom. No, the top right corner.
Yeah, this one. Yeah.
While indexing,
yes.
It is simply, in my experience, it is doing once only.
Yes,
upon
it is
upload.
it
Is
is
it okay?
one, but we may need to do re-indexing if there is a lot of new documents come on. It's not like everyday activity, but depends on if you want to, because this is not like one time. Mostly it is one time to start with, but your policies are changing, maybe new regulations are coming, new privacy documents are coming. Maybe once in a while we may need to update it.
Okay, given the document number unchanged, okay, I upload two document, policy document and stay as the two.
Yeah,
Will the chance increase whenever I ask more and more about the policies?
exactly.
Will, will the chance increase, growing in the index database?
Yes. So if you are adding more data, if you are replacing something, it's a different thing, right? If you are replacing one policy with another one, some 100-page document is there earlier, you are going with a new version of it, then you may be
Sorry,
replacing
Professor.
it.
Sorry,
Yeah,
I just correct my question. My
yeah,
question is, given the number of document is unchanged all the time,
unchanged. Okay.
okay, I just upload once, and that's all.
Upload once. That's it.
Okay,
Yeah, one time.
along my queries, okay, I give them okay 1 to 10 queries. Will the chance increase along my queries? The prompts, I mean the prompts. That is the input. I
Input is
ask
coming.
10
Yes.
questions. Yeah, I
Yes.
ask 10 questions. Will the chance increase?
These chunks will not, that 10 questions from your query were increasing. That is like a query part. You are not changing anything with your indexing. Let's say one query at a time, I convert it into my chunks. Those I am comparing with this and getting the top three. Second one I am taking, getting this one. That's it. We are not touching anything on this.
Thank you. Got it. That is my question one.
Yeah.
Question two is about the embeddings.
Embeddings. Okay.
How can I build my embedding model? Is it in trained model and fine-tuning phase?
Yeah, it's like a pre-trained model. Usually we will not touch that because we have maybe some top 10 models which are there like Titan embeddings or this. So we don't really see a value of changing that unless it is very specific. You have a lot of specialized data which is very specific to do it. Mostly you will use the standard embeddings.
Oh, so this embedding model is built by LLM companies.
Yeah, maybe there are companies,
RAG.
yeah, even there are third-party ones also there, even the OpenAIs and those people also build it. Yes, there are some open source as well.
That is my number two. Thank you. And the last one is about the chunks.
Yeah.
So I'm imagining RAG is given the exam from closed book to open book. That is what you have described.
Yeah. Yes.
Yeah. So my question in this line is, the LLM is going to hint by the three chunks retrieved by the index vectors.
Yes.
Yeah. Before LLM is answering the whole question.
Yes.
Given that the output is the orange part.
Yes.
Oh, okay. Understood.
Exactly. Yeah.
Okay. I have completed my question. Thank you.
Perfect. Yeah. Deepak.
Hi, Professor. Just in terms of the RAG, are we saying that the RAG enables the LLM to, not hallucinate and say that I don't know, like when it doesn't have a set of, or are we, in other words, are we saying that the RAG enables the LLM to restrict its boundaries to a certain set of like data, which is going to search from it. If it doesn't find the answer, it's going to come back and say, I don't know the answer because I don't the data I have doesn't have the answer, or like how what I mean, because it is a constant problem today, right? Like
yes,
and then it's constantly, if it doesn't have the answer, it's making up something.
Even this also, here also it is possible because you are talking about that you need to control from. So if you ask me, hallucination can be controlled with RAG? Yes. But by using RAG, am I completely eliminating? No. So the point is, we are trying to confine some of these inputs. If you see here, what I am doing is LLM general behavior I am not changing. I am giving extra chunks for it so that it will give me some relevant answer. That's it. The same problems what you have in the regular one and all prompting, giving some hallucinated, or maybe let's say these are also not getting into the right set of answers, it may hallucinate as well, right? So the point is we need to go along with the prompting technique this is a RAG combined with prompting is what we will be able to see, because first we will try with the prompting only, right, before come to the RAG. Then when we come to the RAG, we are giving some more external information where the LLM has no knowledge. Even React, if you think of also, that external knowledge is not there even if you are using React as well. You can have an entire system having the React pattern, the prompt engineering, then RAG, the same similar structure will go. Only thing is you are getting some external information also as another link. That also may not answer your question, for instance. Then you are getting from RAG. Entire thing what you are talking about is before the final LLM generate your answer, these are all inputs for you, either from external knowledge or from your enterprise retrieval based. You are augmenting that information to be context rich, right? So we are enhancing the context is one word I can tell you in the last 1 hour of our discussion.
So it's not just basing it on its own memory, but it's also like augmenting with the.
Exactly. This is what augmenting it. Okay. Yeah.
Thank you.
Suvir.
Yeah, Prof. So I have two questions. Question one is, assuming that me, or in this case, my enterprise needs to set up this vector database,
Okay.
would it be safe to assume that the security of the enterprise data that I'm uploading in the vector database is now my responsibility and will
Yes.
not either get used to further train the LLM and therefore dilute the confidentiality of my documents?
Yes.
And two, also the longevity of how long I would want this data to sit in the vector database depends entirely on my system administrator. When they
Yes.
want it there, they can keep it. When they want it, they can delete it, update it. Would that state both these
Yes.
two statements be correct?
Both are correct. You want to have
Got
control,
it.
and even I will extend that your thought process. It is your responsibility to keep it updated as well. Suppose if you have two
Got it.
versions, policy and all. Yes.
Understood. Okay, question number two. What would be the fundamental difference between RAG via the system administrator setting up an independent database in which I assume this enterprise data could live indefinitely, right? So long as we
Yes.
keep paying for the database, the data lives indefinitely, and I would imagine maybe embeddings need to be updated as and when versions of LLM keep changing. What would be the difference in this scenario versus a scenario in which today, on a retail format, if I log into ChatGPT and I put in a prompt, ChatGPT also allows me to upload a Word document into that prompt itself.
Yes. Yes.
But I would imagine that is limited to the instance that I'm interacting with ChatGPT
Yes.
in, and that data is only cached and not getting stored in any format.
Exactly. That's not a RAG-based system, but it's like a prompt we are giving some more context. You are not
Okay.
comparing anything with the chunks vectors and all that. Yeah.
Understood. So it's basically if I upload a document into ChatGPT retail version, it's just an elaborate prompt.
Elaborate prompt. That's it.
Okay, got it. Understood. Thank you very much.
Yeah. Yeah, Vin.
Yes, Professor. I just have quick questions about the embeddings and indexing.
Yeah.
Why? So embedding is to vectorizing. So we're
Yes.
supposed to do vectorizing before putting in chunk,
Before
putting in
putting
indexing, right?
before putting indexing. Yes.
So it's supposed to be vice versa.
No,
And
that is the indexing is the box I am talking about. This is the process, and this is the box I given it as an input, generation, retrieval. This is the name I am giving it to that. So I am not saying the embedding will come first or indexing will come first. I am not defining that.
oh,
This is
I'm
the flow.
sorry. Yeah,
Yeah.
sorry. It's the name of the box.
Yeah.
Sorry.
Yeah.
Okay. And then second, RAG. In real life, do we get like do we do RAG? Can we do RAG ourselves, or
Yes.
do we? So whenever we put external information into LM system, it is called RAG, right?
So external system you may have, suppose if it is not an enterprise system and all that, maybe some general information is available in public, you don't require to store it also, right? So there you can give a React pattern, maybe some kind of LLM is getting some information from Google or anywhere also is possible, or it can be an external tool calling. But the point is, nobody will have information which your enterprise have. If you need, typically the RAG usually approaches whatever the public information is not sufficient for LLM to answer, which are very specific in enterprise AI, we will recommend you to go with the retrieval augmented generation RAG.
Yes. Sorry, I should be clearer. So in real life, do we do RAG using the same vector company? I mean, those vector companies, do they provide
Provide what?
like one of those vectorized companies?
Yes, let's say ChromaDB or Pinecone. Those are the tools. What they provide you, they will provide you the structure. That's it. They don't have any access to your data. It's more like Oracle database you are subscribing, and you have tables, views, and all that. That is like you, right? The same way here also. They are just providing you the structure in terms of this where I will store, and this locally you are storing it or cloud. It's up to you. But you are creating this particular indexing or all the chunks and then similarity index.
Yeah. Sorry. Just to clarify, Professor. So if you do RAG like tomorrow, what do you actually do? Do you like contact, do you need to use the vectorized company, database company, something, or you can build it yourself with one of the, I'm assuming that we can build it ourselves.
No, we need to decide in terms of where you are going to store it, right? Let's say indexing. We talked about an hour for the vector database prior to coming to this one, right? You need to decide whether it is a open source, whether it is a closed source. Where you are storing, you need to have control, right?
Yes.
You decide that. It's not like every 6 months or every 2 months you are changing the decision, right? Usually you will stick to one because otherwise it will be unnecessary rework, re-indexing and all. So once you decide, it's you don't require to contact that unless you have some issues with the database and all that, right? So it is in your control only.
Okay. Thank you, Professor.
Okay. Yeah, let's make it quick because we are spending too much time now. But it is important that I'm taking questions. But if it is a repeated question, you can skip that. Otherwise, specific question, please go ahead. Yeah, Jansi?
Okay, Professor, maybe I made it very small. So you mentioned about the chunk size and the number of chunks. So you remember in the beginning I mentioned about I done this exercise with Google Colab. So in that I remember in the coding I have given the chunk size and number of chunks. So is it
It's like a
something
chunking. It's like a chunking strategy we need to give where
okay, got
there
it.
is a overlapping. You can define the chunking is more like okay the 100 characters or the fixed length or maybe semantic level you are going by sentences or how much of overlap you. There is a kind of a chunking strategy. You have control of it whether you want to do programmatically or maybe settings.
So that means it's in our hands. It's
In
not
our
that
hand. Yeah.
automatically decided.
No. It is in our
That's
hands.
what I want to confirm. Thank you, Professor.
Yeah.
Clear.
Yeah. Niaz, you have further question?
Yes, Professor. During this process, the LLMs will not update its own weight. So hence, it is not observing any of our proprietary document data.
Nothing. It is nothing to do with the these weights update. Yeah.
And I can do this with a externally hosted LLM also through an API. I must be able to inject the context.
Very true.
And those companies which are hosting the LLM are expected. I mean, even if they are extracting the chunk vectors, they will not be able to gather a lot of confidential info because all they are getting is a vector. Is that correct?
That's it. And mostly they are doing it encrypted and all that. So they won't be, as per our enterprise AI policies, so they will not have access to these data officially.
So technically, hosting it internally, it is not going to give a great benefit because of this architecture. Is that correct?
What does that mean?
Like hosting the LLMs locally would require a capex. Now,
you are talking about the hosting the LLM. That depends on the RAG doesn't have any influence whether you want to play with the LLM locally or with your API based. Doesn't matter.
So most of the times the cost justification comes from that we don't want to expose it, but we can have a local RAG engine whereas the LLM could be hosted outside.
Anywhere.
No
problem on that.
Yeah. And in the start of the lecture, you were mentioning about the Llama for the localized execution. Even DeepSeek and a few of the GPT models
you can go local also. You can be local on that. Qwen, DeepSeek, Mistral, they also can be local.
Thanks, Professor.
Yeah. One last question, Sudhir.
Yeah, Prof, forgive me if I misunderstood while you were answering Wen's question, but you said that the enterprise data doesn't necessarily need to be sitting inside a vector, a vector database, it can also be pulled from somewhere, i.e., some kind of connector, MCP, API. So, for example,
those I talked about the React. Last time I have a React kind of a design pattern, right? Not the enterprise data. Suppose some external, by the way, if this is CEO, Altman and all that, let's say this can be some external information also, right? It need not be within the OpenAI environment. Some information may be there in the external. So that external information, I can have a tool calling to get to that also is what I was mentioning as an extension to this.
Such as Google, like it could be a Google Analytics data, it could be Amazon Ads data, so on and so forth.
That's perfectly fine.
Got it.
Okay.
Yeah, thank you.
Yeah, I think a lot of questions on those. That's good. At least you are getting the gist of it, and then a lot of practical questions, right? Hope that is helpful for others as well. So now, before I go into a short break, how are we doing on the time? Yeah. So then let's see this for your digesting a little more. Good that we took a break there so that you understand completely. Otherwise, this will be a little more complicated for you. This is one, and then only one more will come in a approaches point of it. These are the 2 points which we will be able to do it. After that, we do have an example to implement. I will give you a gist of it and we'll take a short break and come back. So what we have done so far is a naive rag where we have, you can see the same format. It should be very clear for you now. If it is a user and query, right? So that's where the user is there. And then this is what one-time effort of document indexing. You are pushing to the retrieval. Then you can observe the term. Some of the people are asking like Niyaz and all, right? So it's a frozen LLM. I'm not updating any of the weights there. So I'm giving, that means I'm just getting a little more context from the prompt from the retrieval and pushing it to frozen LLM, getting the output. It's a simple rack, what we talked about so far and answer lots of your questions. One change is the same query might not be, let's say, self-sufficient. Maybe I need to add some pre-retrieval. That means query rerouting, query expansion, some more context I want to provide. You can do that for better performance. Or even after that, the retrieval, you remember there are retrieval means what? The chunks, top chunks we are getting. Maybe there also I can re-rank, summarize, fusion for the complex cases. So these two also can help you to get it into advanced track. The last part is having some memory. Then there are also some different patterns are there. Within that also modular RAG, if you are thinking as a general one, you can have naive RAG, advanced RAG and all. There are some more patterns like this. What is happening is we can have retrieve and read. So retrieval is a pre and post and read. So in between you can have re-rank as well. So what you see here, these are like modules, individual modules. Here I given a flow, existing flow of naive RAG, which you are comfortable. I'm adding pre and post. That's it. Whereas in the modular RAG, the same I can show it to you here. I am retrieving and reading it. Whereas retrieval and read can be supported by rewrite and re-rank. That's what here I am rewriting it, re-ranking it. Whereas the other ones, if you go in a different order, it can go in a loop, the same retrieve, read and all, it can go in a loop. Similarly here also, these are the different activities. I need to do a retrieve and RAG. Maybe in between I need to do a rewrite and re-rank. Those kind of a thing, if I need to store something, if I need to search something. So these are like individual modules I can plug and play and then structure it in a design pattern what I need, right? So that's what the modular RAG looks like. So if you see an extension of what naive RAG is enhancing the query, at the end, you are getting better context and the same is being retrieved. Similarly, you can make it more modular as well, what we are talking about in a repeated fashion. That's an extension to the regular RAG. Okay. So if you are good so far, then this is exactly the same where I'll take the questions before we take a pause. The same thing I'm showing it to you so that at least you will understand. Retrieval augmented generation, there are questions. What is that? This is like your prompt is a technique. Retrieval augmented generation is also technique. For retrieval, we are using vector databases and then we are augmenting the information and then pushing it into the LLM for generate. So that's where we have these retrieval granularity can be token level, phrase level, chunk level. We are seeing, right? At what level? But general or default option is at a chunk level. But you want to go, no, I need to get a retrieval of a document. Yes, you can get the entire document as well. Similarly, we have shown some optimization is possible at a indexing level, query level. We have shown it to you here also. Okay. Similarly, if you go to the embedding, then the last one will come here as how are you augmenting it in an iterative fashion? in a recursive fashion, in an adaptive fashion. That's what I will leave you for your just observation before we before we go for the break. But what we are doing so far is we are trying to retrieve it either simple way or little more complicated way. Ultimate aim is to get the better context. Once you have that, maybe we'll re-rank and all that and then push it to the LLM for generation. So that's what we have. So I do have one hand up. Mother, yeah, go ahead.
Yeah. Prof, in the prior slide that you showed the 3 types of RAG,
Yeah.
would you be able to just explain with an example, like, for example, name RAG, what is one of the case wherein we're playing vanilla flavor that would real and with an
Yeah.
example that really helps?
Yeah, so the same example you can take, the previous one. Now, if I give the same query, my expectation is the simple NiveRack can do the well. But let's say if I'm not giving this many line, I'm just asking one line only. What is happening to the Sam Altman? Just one line of prompt. That may not be enough. Then, to get the better answer, I am trying to add some more information of rewriting the prompt. Based on what, how are you rewriting it? Maybe another LLM you are using it to do that, or some more local expansion you are trying to do. That is up to us. But you are able to expand some more query. Once you retrieve it, you are seeing in this one some chunks here. These chunks by default we are not re-ranking under any of them. Then there is a retrieval. How do I decide whether I need to re-rank? There is a retrieval accuracy. There is some specific retrieval parameters, because if I don't retrieve the right kind of chunks, can I get the better performance from RAG?
No.
Then I need to evaluate it. Maybe there is an evaluation method at the retrieval. If it is not good number of chunks, which I'm expecting good chunks, then I need to go do a re-ranking. So based on the self-checks what you need, I'm expanding the same example for the advanced RAG. When do you need to go to modular RAG? Modular RAG, I'll see it is just a generalization of it. Otherwise, the same nav RAG can be part of it. Advanced RAG can be part of it. Maybe some more patterns you can go with that as well. So depends on how well you are able to write your prompt. If that is because each of them have their own style, right? Experienced prompt engineer versus the other people. Then we are trying to augment some more information through these patterns is the good example I can give it to you.
Got it.
Okay. So any further questions before we go for a short break?
Yeah. So Prof, the
Yeah, go
response
ahead.
time with the name RAG would be the least compared with the
Definitely.
modular RAG.
Definitely. Modular RAG also depends, because modular RAG also I can tell naive RAG is one small subset of it, right? So if you go with that, naturally, if you are going with any of these retrieval, re-rank or rewrite, definitely it will take a little more time.
Got it. Yeah.
Okay.
And of course, totally different question. I know we are discussing about RAG over here, but I've just read through an article that RAG is now kind of obsolete. We are going with vectorless RAG because
Maybe,
of the chunking and other stuff. It has its own concerns with the way chunking is done, semantic search is done. So would you also be covering the vectorless RAG for us?
Vectorless RAG may not be in detail now, but we will call about something on the cache augmented generation, little bit more on the RAG, and then we will discuss on the vectorless, what are the pros and cons. It's still not established. Even people say the RAG is dead. But at least for next couple of years, because we do have pros and LLMs, we have enough things to solve. Before we get it into some more better methodology, it is still going to be there. And as of now, prompt and RAG itself is solving 70 to 80% of the problems for us. When we are going with the better approaches as the industry is maturing, we'll go with that. I'll cover a little bit of that as well later.
Got it.
Okay. Yeah. So other people who asked the questions, I think 5-6 people, right? So are you comfortable till this time? Any last set of questions before we jump? Let me know. Yeah, Niyaz.
Yes, Professor, this advanced RAG pre-retrieval, it has 3 phases: the query routing, rewriting, and expansion.
It's not like 3 phases. I don't require to do all 3. If I just require to do expansion, I will do. These are 3 different approaches we are talking. Combine that as a pre-retrieval activities.
And for this purpose, it uses a different LLM?
You can use LLM, you can use, or maybe you can have your rule-based system. You can take about, suppose some keywords are there. Okay. And based on that, I want to get some more information. It need not be LLM, or it can be LLM as well.
And before presenting it to the frozen LLM, again, it does a re-ranking, summary, and fusion. And there also, it could be either a rule-based or a LLM-based.
Traditional system or LLM-based, yes. We can do it.
Technically, the advanced RAG would be a bit more latent latency involved.
Definitely, latency involved, a little more process. That's why first we need to try with the naive RAG. If it is not working, definitely it's not like all the you need to do all the rerouting, rewriting, expansion, re-ranking, summarization. It is like techniques we are talking about. What is really required, that only you will do it.
And when it comes to modular RAG, it's like a iterative
Approach. Yes.
Okay.
This
And
is a very costly thing to go to that. This is the last option which you need to think through.
And so it keeps on retrieving, refining, and so on. And
Yes.
what would be the barometer for it to say stop the iteration?
Exactly. So LLM usually we will say, otherwise it will go into infinite loop. It is not going to retrieve, right? I need to after 2-3 iterations of this, typically I need to put a external benchmark saying that you just cut it out, right? So that I can control it from the coding perspective. I means anybody who is the developer. Or it can be a performance based. We need to have some exit condition. Otherwise, it will just unnecessarily go into the loop.
Thanks, Professor. A lot of info. Thank you very much.
Yeah. So hope the other people who ask questions also are able to get so far and clarified. Then let's have a short break while you are coming from the 10 minutes break. If you are coming early or just seeing it, please have a look at this. And this may be the last complex slide I can sell for today. Then once we are back, we will go into little more details of what practically happening, how are you evaluating. We'll take one good end-to-end example and show you a lot of slides in terms of as a screenshot how we are doing it. So even if you have any further question how we are really implementing, it's my duty to convince you. Mostly conceptual point we are covering. One more we will take it into this so retrieval we completely covered. Generation is already there. Some augmentation, RAG, augmentation is what you are talking about here. Once we do that, then we'll complete with an example. So hope you are able to follow all of you. We'll take a 10 minutes break and come back. Okay, are we good to go?
Yes, Professor.
Yeah. So try to digest even, don't worry. So some of you are asking, you don't require to feel it is a naive question, this and all that, right? So everybody needs to be comfortable. If it is a repeated question only for some person, I will ask you to wait till the end of the session and I'll answer. It's my duty. But everybody should be able to get. So actually little more interaction happened. Is it helpful for you? Because these are all related questions, important concept. I'm able to take those. Any of you feeling that it is diverting thing, then I can limit some of those and then take towards the end. Are we good with the flow so far?
Yes, Professor.
Okay, fine. So usually I need to balance it. Otherwise, you lose the time. But in otherwise also, even if you are taking a little more time, depending on the context, I'll ask you to wait till the end. Then we will balance the rest of the things. Okay, let's go ahead and then come back in 10 minutes. Welcome back. There are some questions in the chat. Sharing my RAG custom GPT sham. Okay, let me see what it is. Oh, okay. You just made it into Singapore Decision Intelligence. Very good. So what is
Yeah.
the what is the tech stack you've used here? Is it like NavRag or anything more where you stored this VectorDB?
It's in the it's in OpenAI custom GPT.
Okay.
Yeah. So the problem statement is residents in my country, Singapore, face problems like cost of living, housing, reskilling, looking for jobs. Okay. And because it's a small country,
Yes.
very constrained, so the citizens can make very costly mistakes when they decide what skills they want to upgrade to, what schools they want to go to, what projects they want to invest in, what company they want to develop a career in. So when I built this GPT, I feed it with the knowledge base, KB, knowledge base of evidences from various ministries of the country. Okay, like Ministry of Manpower, the salary scales, example, one of them that I feed inside. And I treat RAG as something like an evidence, the latest evidence. So when my users prompt, they sometimes get hallucinated answers, okay? But let's say last month, the Prime Minister revealed the budget statement, the budget statement for the country. Now that is evidence, real, is evidence, the budget statement. Now, what I found that when I feed that budget statement into the GPT, it's like a RAG, then suddenly it everything falls into place, the context. It draws the context of any queries, drawing information and evidence from the budget statement. This is what I discovered. Yeah. And
so we need to sign in to run it, I guess, right? So
no need. It's free.
It's free, but we are sorry, but you don't have access to GPT interactions, is what it is saying. Let me retry.
Oh.
When I don't log in, I got that error, but okay. I
Same,
think
Professor.
when I tried, but when I retried, I think it is trying to give me. Yeah. So first time it is coming like that, but yeah, good approach. Just one question: when you are depending on this OpenAI thing, so you are just controlling the what documents you are uploading or anything else in terms. I don't think you are controlling the storage and all that, right? So your job is to give this, and then this custom GPT is able to provide you the relevant answers in a RAG fashion. Is that the way you implemented? Yeah.
Yes, because I'm not retraining the LLM.
Yeah, exactly. That is not going to be. Exactly.
Correct.
No fine tuning, no
Correct.
training. Yes.
Exactly.
Yeah.
Exactly. Then I draw latest evidences. Yeah. Into the LLM. And then it was amazing. My users are able to make decisions on what kind of housing to buy. They are able to make decisions on how to retire. You know, how much savings do you need to retire?
Do you need to have? Yeah, that's important question, right?
Yes, in Singapore, and what kind of government assistance schemes are there? You know, to help those people who fell through the gaps, for example. Wow.
Exactly.
Yeah, it's very powerful. Yes. I just want to share that.
Yeah, I do agree. So because each country will have their own policy, everybody may not be aware of it. No, these GPTs kind of a thing will be helpful. For instance, even Australia has some scheme to retire. At what age you need to retire? So I heard from some of my colleague there. So if you are retiring, they will take based on their scheme. I didn't remember the scheme name. So based on their scheme, the last 2 years average will be taken. So some of you, some of the professors whom I'm aware of there. So when they are in active career, whether as a dean or as a professor, full-time professor, if they take a
Yes.
retirement, then that may be beneficial, right? So that may be their intelligence, or they,
Yes.
they can work on later as well as an emeritus or maybe as a visiting. But from a financial benefit point of it, if they retire at that time, this scheme may be beneficial. That kind of inputs are very specific to that region, very specific to that knowledge. Where the general GPT may or may not be. It can also give if it is a policy and all. But this kind of custom kind of a thing is little more reliable and then trustworthy.
Yes. Amazing.
Okay.
It's wonderful.
Good. Thank you.
Thank
So
you.
then I have Andy talking about some more big messages. So let me see. You want to build some kind of an SLM? Good. We'll select an LLM that aligns with Hong Kong's cultural context and present with a vast number of questions. Okay. Regarding this education policies, during this process, I will instruct the model to provide chain of thought reasoning. Good. Generate extended follow-up questions. So this generated data set will be used to train SLM. So, but only I have few questions. So let me read that and then answer that or ask you back. Through this training, the SLM will fine-tune its internal weights to output the high quality answers matching the data set. By doing so, I'll obtain expert model capable. That means you are trying to update the weights. As of now, what we are talking about is only not touching those weights at all. The surface level, whether it's whether it is retrieval augmented generation, prompt, and all that. Since society continuously evolves, I will feed the latest dynamic data into data cleansing pipeline for pre-processing. This process, the data will be passed to a text embedding model. Yes, that's correct. When a query is received, the system will convert it into user's prompt, this and all. Okay, so that means you want to have your specific LLM to start with every time. Maybe you are calling it as a specialized model for your thing. Then on top of it also, yes, you can apply RAG because you can't update even SLM every now and then, right? You will have some kind of a freezing time. Then you need to augment for the latest ones. After that, if you want to update it further on a frequent basis, that's fine. And that process is looking fine for me. That is an answer for Andy. Okay, let's go into a little more observation here in terms of what we are doing from an augmentation thing, right? So if you see here from an iterative and recursive and these approaches, what does that mean? So where are we? Initially, I'm talking about the two RAG types, but now this is more on the addition to most common ones. This is what augmentation process. What does that mean? You have query and then your response, right? So you are retrieving it and then generating it, and then at that time you are trying to make a judgment. So some of you are asking, right, how many times I need to loop in? You can put a max threshold or whether 2 or 3 or 5. So you need to put some threshold, balancing your latency as well. And definitely there will be some kind of a threshold level of acceptance. Okay, when you get there, that is what the iterative approach is what we are talking. The recursive approach means we are talking about, okay, beyond 2-3 times, the same retrieval generation, I don't think it is yielding from my practical experience. Then I will go into recursive approach saying, yes, you are providing more contextual information to retrieve, but after 2-3 things, it will again not yielding the right set of things. Then we want to break down the complex problem step by step. First you retrieve, generate, then go into the transformation, decompose further, and then try to add that information. That's the kind of recursive. Whereas the last one, adaptive, means it's flexible and active control of the generation and thing what you are having. That means what? Only difference is if you see these orange portions, this is what the judgment. I have one more judgment where if you have a question which is retrieve on demand, that means what? You have enough of this information, you are making a call, then directly generate it. You don't require to go to retrieve again, go into the path, right? So what does that mean in summary for you is iterative retrieval involves alternating between retrieval generation, allowing the richer and more targeted context to come from a knowledge base. Whereas middle one, the recursive retrieval, involves gradually refining the user query and breaking down the problem into sub-problems, and then continuously solving the complex problem to the retrieval and generation. That's where the second one is. When to use what? We will come to that. The right last one is adaptive retrieval focuses on enabling the RAG system to autonomously determine whether the external knowledge retrieval is necessary, similar to your what you call the React kind of a pattern, right? So if it is necessary, when to stop the retrieval and generation, often utilizing the LLM generated special tokens for control. You can here also to control it, you will do it. If you really need external information, come here. If you don't require it, you make a judgment. That's where adaptive term is coming. Every time I don't require to retrieve and then judge whether it is correct or not. If I don't require it, I happily generate directly. I don't require to go with the path. Is it making sense or any specific questions? Yeah, I think I am seeing Aniya's raising your question, your hand. Yeah, go ahead.
In the recursive, we use LLM for a judge, recursive and iterative.
Recursive and iterative, I don't think we require to have the LLM as a judge. The judgment can happen in terms of actually the self-judgment is there. It need not be so. If you observe, the LLM internally also can give you score. It doesn't require to be an external LLM as a judge. This LLM will also, if it is not, sometimes if you see, it takes, let's say, 10 seconds to get your formalized answer. Sometimes it may take 20 seconds, 30 seconds also. Why? It is going 2 iterations, 3 iterations internally. Who is, I am not controlling it, but LLM internally not satisfied with the answer what it generated. So it will go back. So that also possible.
How does it happen, Professor? Like
internally, they have some kind of a score for this kind of a query, for this kind of a generation. It try to evaluate itself, and there is an, if you can print that also, there is a, we used to call something like a confidence score. So, but directly I can't 100% believe what the score it is giving. Sometimes it may be hallucinating and misleading also, but at least initial checkpoint, because you are not guaranteeing only one iteration it will take and then come back. I have externally enforced in some of these production level systems, don't go beyond 3. Okay, because I am not able to balance my retrieval, because I'm guaranteeing some information within these many seconds to the customer or maybe the client. If that is not happening, then you come back and ask some more question in iterative way. There are other techniques to follow. But when you are taking this context as granted, I can't stare at the screen beyond a limit and it needs to give me some information, or it is not satisfied and then come back instead of giving partial answer. It will try to, okay, I am trying to give you, ask you some more clarification. Can you provide? So that's the approach practically we have followed.
Now, that score calculation, is it using a vector Hamming distance calculation?
I have some of these in terms of the RAG, some calculations what you talk about. Each LLM may have their own style of doing it, but it will try to just to give you that how much of confidence I have on the answer. It's not like 100% confidence. Sometimes it may be only 50 still give. So that also sometimes we can control ourselves. So if it is not confident beyond certain limit, don't present the result also. LLM maybe tend to present it, but we can control it.
And as the augmented information is coming from an external database,
yes,
the judgment will not be able to detect the congruence between the query and response, and that can.
Good point. Good point. But the point is, here the judgment means how well they are able to generate. It's not really. So, do you think LLM has a common sense to understand whether they are my answer is correct? No, it doesn't have that kind of a common sense, right? It just goes by whatever the calculation it has. That's it. Okay, that's why we keep saying that it can produce grammatically correct nonsense statement. It can correct the grammar, but it cannot correct the actual intent and maybe the correct answer point of it. Yeah.
Thanks, boss. Thank you.
Yeah. So if you are good so far, then slowly let me go into the next step as well. So we do have how are we building this, right? So this can answer a lot of your questions, then some evaluation. That brings the last case study. Case study we can take how much time? What is time now? Yeah, we have almost like another hour, right? Close to 45, 50 minutes. Yeah, we'll be able to do that. So there I have a lot of slides though, but it is go as an example to run through. Once you are able to follow, it is easy. So far, I have given the source link as well. So before that, I have 2 points to convey in terms of how are we summarizing overall thing. So even if you have any questions so far, right? So try to follow up, and then I'm not telling anything new here. but at the same time trying to connect these dots in terms of what we have talked so far, and then able to show you what's happening with one example from Azure scenario. Okay, so the same thing, the description of it is what happening. So how are you building the knowledge repository, building the vector database, the dynamic retrieval mechanism, how it is happening, how are we integrating with LLM, and how are you testing it. These are the 5 steps I'm trying to show it to you first. Then I'll come back to this slide. What are you doing here is, first I need to do this part. Okay, I will take a pen. So if you see here, this is maybe the step 1 where you have document library. That's where your knowledge base, and then having this document chunking process. Okay, so then we do have these different sections are taken from there. Then comes converting the docs. This is one OpenAI service, text embedding 3 large. Like that, you have some default embeddings. Then converted it into embeddings. This is the step 1, which you will be able to do before your actual RAG implementation. Okay. After that, what is the connection here is, yes, I do have a user application is the second step. Then we are asking some questions. The direct path can be without using the RAG here. The RAG is happening here. So without RAG, if you are talking about, it can be the same question, go to a prompt, get to a GPT-4o or 5, whatever version, and then summarize or question answer and then get the result. This is the simplest path, right? What you have shown you earlier in a flow diagram. Here now I am talking from an Azure AI setup. But if you need some more information, the same question is uses the text embedding 3 large, because I need to use this one and this one should match. Otherwise, it will not be apple to apple comparison. I will use some kind of vector. It will have some other vector, and then the format embeddings will not match, will not give you the right result. So that embedded question is being pushed to this Azure Search Vector Index. The relevant embeddings, the chunks, n relevant sections, those things or sections or chunks will be an input for me. That goes to as an input to the prompt. This is more like this is added to the prompt. Okay. Then we are going to the LLM and then we'll push back to the result. So this is the flow, nothing new, but only thing I am using on top of Azure service, the entire flow. Okay, so now if you have any further things as well, if you are taking this as an example, the deck. Okay, so if you come back and see, first you need to have the knowledge repository. That's why the document library, right? Aggregate all the sources ranging from structured, unstructured, and all. Establish unified things. Then comes the transform this to the knowledge repository into numerical representation. That's what we have done. Then dynamic retrieval, when user queries, the RAG utilizes the embedding model to convert each query to vector. We have shown facilitating search and document index. The most similar embeddings are then retrieved. Then match the retrieval context with this is what the next step you are talking about, with user's prompt, and present it to the LLM. LLM incorporates additional context to craft the response. After implementation, enough thorough testing is required. Then comes the evaluation of vector database performance using, that's where we are talking about precision and recall, this kind of performance. Okay, so let me cover this part also, and then we'll take a pause. So now, yes, we have something like RAGAS as a score. Now we understand the entire flow now. Even if you have any doubt of 1%, 2%, 10%, next half an hour or 40 minutes, we are going slowly one real world example, how things are happening, double clicking on the architecture, what you have shown to you. Okay, so but before that, let's understand what is we talked in between, right? So how do you get the retrieval part? Some of you are also asking, right? How do we judge whether we receive the right set of data, right set of chunks? So that's why we are not talking about the overall RAG performance, but we can split it into 2 parts. Whether we retrieve the right part, then if it is not, then it is still problem there. If it is retrieved the right one, not getting the right answer, then I'll blame the generation part. Okay, so the retrieval process sets the context and LLM carries out the generation by utilizing the retrieved information. This is what the general RAG means. But what is happening here is you are asking a query, getting relevant documents, but before that I want to measure how retrieved ones are relevant. Then LLM I'm trying to give for generation, getting that answer, okay, determine whether the retrieved documents are relevant given in the query. Then comes the RAG score. How much is the RAG score for me? So what does that mean is we are trying to say from the RAG score, it's a combination of retrieval and generation. In retrieval, I want to see how much of the precision, you know the precision recall, right? So now we are talking from a context precision and context recall. Whereas generation, how factually accurate that answer is. So how relevant is the generated answer is. So these kind of generation kind of scores are also available. Because these are the only ones? No. We do have few more metrics, but these are the standard ones people can refer. Okay. So before I go to the last part of the example, any specific questions at this stage?
Professor, the LLM and the vector storage need to be very closely placed to reduce the latency, right?
Come again.
Here, the Azure AI search vector index, it is wherever the that's being stored, and between the LLM engine and this vector index, there will be a frequent access. Is that correct?
Yes, it may be in the cloud or it may be in the distributed fashion, but they are frequently connected. Yes.
The performance will be impacted by how quickly they both can access, right? Instead of caching it locally, it has if it is closely placed, it will be. And you were mentioning that some vector DB companies, so those they are providing the framework, but the vector itself will be residing locally to the LLM. Is that correct understanding?
No. When you say locally available to LLM means what? Somewhere we need to store it, right?
Whichever server the LLM is there, and that there is a tight InfiniBand kind of access to this storage.
But the cloud will take care, even if it is not, let's say you may have a local storage, but the LLM service is happening somewhere in the cloud, but still you will be able to do, right? Everything, say you are talking about local setup, I'm talking about a global setup only. So overall, you have, whether you have a private cloud, whether it is a public cloud instance, depending on what your enterprise privacy licenses are, you may have the LLM actually not residing in your environment, right? That can be in a cloud. Even in the Azure AI search vector index also may not be storing locally as well. You have a local option or a private cloud option is also possible. But from there, whether you want to get a LLM local access, that will have impact on latency. I understand your point. But the thing is, when you are trying to connect these information, whether one is a local and this one, maybe there is an encryption also possible, so that there is no leakage of information. Those things are very much possible, right? One is proprietary thing, other one is this. But where exactly storing, we don't require to demand. Both needs to be next to each other. Need not be.
There could be a GDPR restriction that data cannot cross.
Okay. Exactly.
Right. Thanks, Professor.
Yeah. So others, are we good so far? Before we go to the last step? Yeah, please. Go ahead.
These embedding, stick to this line. These embeddings are interfering operation conduct in GPU or actually CPU operations?
You are asking whether GPU or CPU operations, right? So mostly,
exactly.
These are, let me tell you, from an Azure only, in a cloud level, you don't require, unless it is very complex, lot of data. It can, because we are not talking about really training anything, right? Just doing some chunking, tokenization, and converting into embeddings. So GPUs are a little better because we of the volume. If it is not really a big amount of data, even CPUs also decent enough, depending on how many cores. And that is a one-time activity. For that matter, if you are constrained on the budget, as you also know, right? So then we can go with the existing hardware. That should not be a problem because this is the offline activity, right? We are not doing something online.
Okay, so suppose we can handle this on buying some CPU to achieve this RAG. not necessary to buy GPU to achieve that, right?
Yes.
Okay, understood. Thank you.
Welcome. Okay, are we good to proceed further? Sure. So when we go a little further, so here in the next whatever the half an hour, what we are going to talk on this, I don't think we are going to introduce anything new. So everything what we talked about so far, what I clarified to you just before the break. So we are going into a little more detailed way. So pause, give me a pause whenever you need this other explanation. Otherwise, I do have maybe around 15-20 slides just to give you the overall flow. How are we trying to demonstrate this, right? So on top of it, if you require anything on the RAG kind of a code also, let's see if time permits, we will, as an optional thing towards the end, I will try to show that. Last time I shown you the prompting, Olam and all, even RAG also, hopefully we can try to run as well. So otherwise also I'll give you the code if you want to see, I can have a glimpse of that. So from a LangChain is what we are using, but so let me tell you what is the use case we are talking. The example use case is question answer over unstructured data. Okay. So when you talk about this unstructured data here, so we are talking about these, just see the flow now. You have a question. Okay, let me show it to you here. You have a question, then I do have data here. Then we do have the chunks kind of a thing, what we are trying to retrieve, and then go to LLM. This is what the flow we have seen so far, right? So here also it will continue, but I'll go a little more detailed way. Okay, the same thing. So when you have a question, you are converting into using the embeddings. Then, by the way, before we go here, this is what it is happening. The YouTube video, the transcript, go to this particular vectorization, then push to the database, right? So this is what the one-time activity is what we are talking. When we are getting into that level, so you need to have some kind of a prompt template where we do have instruction, a lot of context, because these are all going into the context, right? And then LLM is coming and then giving you the answer. So that's where we are now trying to see here what's really happening. But let me tell you step by step here, what is the role of LangChain here? Last time, I think Olama to LangChain, we are able to connect and go, but there's an opportunity for me to tell you a little more details in terms of, yes, this is a kind of a Python framework, and this parrot symbol is what you see. There are a lot of tools, prompts, vector stores, then models, what it can add. Then the building blocks is what we are really retrieving it for. Then we do have a couple of examples, POC production also it is possible. So let's understand step by step what is happening. First step is preparing and storing data. Just think of it. You are trying to implement just like we have seen one demo from that GPT thing. So here everybody should be comfortable, even though you have separate session on this retrieval augmented generation. It's good to understand the flow on how it is happening. So in case of preparation, if you go further, what is really happening, I'm just taking an example of YouTube video. It can be any document and all. So the transcript and converting into the vectors. This step also, if you see one by one, first one, I need to have a document loader. It can be PDF, video, any of them. Then comes the text splitter. So how are you splitting into the chunks? There is a chunking strategy, overlapping strategy also. What does that mean? So you do get some kind of characters with respect to, let's say, fixed chunk size or maybe dynamic with respect to the sentences. Then we will have overlap of that as well. 10% overlap, 20% overlap. We keep getting that result of that. Then comes the embedding function, and how do you really convert that into the vectors, and finally, how do you store it? In that one slide, I can tell you from a document loader, one of each of them, again, I'm going into double clicking. So again, document loader, when you talk about, you do have a lot of things. What I'm showing you is a YouTube transcript is this one, but you do have n number of things here where you are talking about even the emails, GitHubs, right? Any of this Reddit. So there are so many such document loaders. What will happen if you don't have any such thing? Maybe you can give the feedback or any open source are there, we can use it as well. So that's what the document loader is doing. Then text splitter, I was talking about that, right? So now you can go into break the text into smaller chunks, maybe 100 characters. You can define that, right? So the different colors, what you can see here. Here you don't have too much of overlap, but usually we can have maybe 10% overlap means if it is 100 words, maybe 10 words will repeat and then go in the other chunk as well. So why do we need that repetition? Because to have continuity, to have a better performance, we have seen the significance role of that. Similarly, embeddings. Embeddings are nothing but your numerical representations where you can go into vectors in high dimensional space. So just like your Word2Vec, you do have like 300 dimensions, 400 dimensions. And when they are similar, what does that mean is proximity in embedding space is what really happening there. So then comes the vector store where it needs to be stored well, search, and then able to retrieve. That's what we are trying to push from the step 4. So if you see, this is the third step, this is the second step, this is the one, that's what the summary is what we are talking about from this. So this is what we have covered so far in this particular part. If you see here, so this is what we covered so far. This is a one-time activity of including this, I can say, like this. Now let's see the next path and then proceed further. Okay, so what is happening is a most used vector. Now, when the storage, I can tell you here, from a talk vector stores, even if you type now, you may not get exactly the same. Maybe a few months ago, this is the one, right? Whether it's a chroma or pinecone, that may vary slightly. Let's say it's not like suddenly every week it will change very dynamically, not at that level. But we do have now what you are really seeing from the top 5 list. You remember some 10 or 11 pointers we talked about. How do you choose it? It doesn't mean that ChromaDB is the topmost. We will directly jump and see it, right? So we will be able to see the reference of it and then get back to us. Now, if you go further on that, where the using this data, what we are really referring to is yes, we do have one-time setup, what we have talked about so far. That is coming as an input. Now the question, whatever we have, and then convert it into embeddings, and then that embeddings will compare. So now we have the extra information. That's what we are talking about, how it is really happening. We need to retrieve it. We need to have a prompt, okay, and then LLM, and then finally there is a chain to take care further. So retrieval means you do have a question and then convert it into embedding, and then trying to get the distance metric within the retrieval documents. Within the retrieval documents, whatever you see, within the retrieval document, whatever we see here is the prompt, right? Once you retrieve, we want to add it as a more context. What we are doing is we are retrieving it, adding more context, and then trying to get the result of that, right? So that's what the retrieval augmented generation. That's what you see here. After that, it is more like we'll summarize, and then I have a few more points to cover down the line. But if you see in the last 10-15 minutes what we covered, we can go one more round of that, is this is what the specific data point, what we are trying to get. Then we go into the retrieval part. That's what you will see here, the retrieval part. Once you have relevant documents, that means go till this point, then push to the LLM, and then it will try to give me the relevant information for us. Yeah, before we go to the last part of it, and then I do have a few more points to cover in an architecture and all that. So while it is fresh in your mind, I'll take one of that. But first preference is what you are trying to do here. Are we able to get the good understanding so far?
Yes.
Okay. So there are people who all ask the question in terms of how it is really working. It should be a little more comfortable now in terms of doing the end-to-end flow. Okay, but feel free, don't worry whether it's a simple question, complex question, my duty to answer. Similarly, there are a lot of, now comes the model provider, right? So till now we are not talking about the model, so they will have, some of these can happen at a Hugging Face level or Olama level, right? So these are the different model providers what we have. And then we can also, it's not like the top one is what it is, the integration part, scalability part, support part, all the things is what we are really talking. So I'll summarize for what we have talked so far, and then there are references. And this is where we usually go into the summary, but I'll take 1, 2 slides on this, what I have as a recap, so that we can cover a little more topic in the next session, right? But here, that also will help you in the summarization. If you see, we talked about vector databases. We answered a lot of your points of why an vector database is required, and then how you want to generate in terms of these vector databases, then whatever the structure of this vector database, this is the structure, this is what we will generate this knowledge repository, this is where we are trying to push the data, and what we agreed on, this is what the vector embeddings is what we are going to there. Then we do have retrieval, augmentation, generation. Let's see, within the RAG, we do have naive RAG, modular RAG, and advanced RAG. I'll say naive and advanced is a subset of what we are talking about. Then comes an augmentation, iterative, recursive, adaptive methods are there. Once you are able to retrieve and augment, then we are pushing it to the generation. That's where implementation of the RAG system is presently working. Then we have taken an example of orchestration with the LangChain for a RAG example. Okay. So what we do further, I do have some references. I'll upload the deck immediately after the session. Then this will take a little more time, but if required, we'll try to cover after this. But before that, I want to understand or give you one more perspective of RAG while it is fresh in your mind. So the same flow I may be giving you in a different way, so that even if you have a small 1% of doubt also, right? At least conceptually, you should be very clear. Otherwise, I'm ready to explain any specific slide to go back as well. And while you are implementing it, because by this time, it should be good enough for you to think through in terms of how you are solving the real problem, right? So that's where we will go little detailed way. So now if you see here, the steps, the red ones is, sorry. So the red one, what you see is the documents. Then LangChain is going to help us to extract the text and chunk up. Those chunks, we are going it into the embeddings. That embedding model will give you the embeddings. So this is where the starting point, where we are doing that activity as one time, right? In the beginning of it. Then comes the question. You can see just follow this. If it is a question, get it into a cosine similarity, and then maybe retrieved embeddings, and then push it is one path. But otherwise, you can go question and then 3B. There is not much link with this. The same question you are going and then coming back as well. That is another path. So what is important here is acquiring information is in 1, 2, 3, 4 steps. But whereas these question embeddings or any of these cosine similarity things or retrieved embeddings, in this one I'm showing you the grant. So the DRE grant, right? So that is the tool I'm trying to just refer, but it can be anything, what we are really referring. Then comes actually the flow where if you see the cosine similarity, then retrieved segments, and then we are ready to push for LLM for the generation. So yeah, Simon, you have a question. Go ahead.
Yes, Professor, just guessing about the memory management of the session context. Whenever the users keep querying on the same RAG, database, the vectors, shall the context grow exponentially in terms of because every time you are embedding the context with the question and also the retrieved information, will it be duplicated upon subsequent query, such that the memory context will be exposed very soon? I'm thinking about the performance issue.
Got it. So then your point is valid in practice. So what we will do there is something like a cache augmented generation. I'm not saying a plain vanilla version is really required. Then you are trying to think from some more optimization aspects into more angles as well. One, the memory you talked about, right? It can be caches, what we are talking about. And then in the cache augmented generation, just for your information, if the frequently asked question is being asked, I don't go for retrieval, this and all, it's already there, and I just push it to the LLM. It's almost like the same path here. I'll try to, if the same query, there is a checkpoint here, if it is there in the cache, I think I have something like that in the previous overall flow. So I'll see if I'm able to cover this. But first you need to go into this part of it where so these things I can skim through next time when we are talking about, but these are the things which will be helpful for you to think it through, right? So that is one level of optimization. Then second thing is in terms of memory, even the same Gen AI or even the agentic AI in future, we do want to have some kind of a control where the short-term memory, long-term memory, not our LSTM standard, but we do have different levels of memory where you want to store that particular information. It is possible that it comes under the design aspects. Does it answer your point?
Got it. Look forward for details soon.
Yeah. Got it. So this is one, and then anything else you can see here. But otherwise, when you have a few more minutes, let me spend. If you are able to cover these points also, then it is easy for me to cover even the pending RLHF or CAG or anything like that, right? So this is example of retrieval augmented generation. And even I can tell you from a prompt engineering perspective as well, we do talk about, yes, this is the database, this is what the information store is. Then within that workflows, I want to tell you here, there is a recipe from role, task, instructions, and context and input, right? So when we follow that, what role we are trying to play, what task you are trying to execute, then what are those instructions, what context you want to provide, along with the inputs. If you remember, you already know these instructions, context, input, and then output as well at a structural level. That's what we are generating, right? So other than that, you can define, it is very good in the role play. So to be very precise that this time, we are trying to make sure, yes, we do have the role play of this so and so. This is what the task we need to execute. To do that, we are giving you the instructions, context, and input. When you follow that recipe with a specific design pattern, it is important for us to see what's really happening where the prompt thing, right? So the prompt preparation is done with the structural recipe, and then we'll be able to push it to the generative AI thing, and it is generating the answer. So for that, we do have some methodologies as design patterns. Then we do have prompt libraries, which is helping us. Okay, those are the things which we want to go ahead from a prompt engineering perspective. Okay, so we can combine prompt engineering along with some examples and then RAG as well. So any questions so far in the entire topic for today?
Could you please explain that RAGA score part a bit?
RAGA score means the previous one, is it? This one?
Yeah, that one slide.
This one?
Not this. It is just before the break you were showing that slide.
Before the break, I'm showing on. Oh, okay, the augmentation part.
Yeah, the score generation part. The right part of it. the faithfulness, answer relevancy,
This one?
context.
Yeah. What is the question here?
These 4 parts, could you how it is arriving at?
How it is arriving at, yeah. So one in case of a retrieval, we do prepare this. Ragas is also a kind of package which is available for us. We can download and then try to get the retrieval and generation. So what you are trying to arrive at this is just like you have a retrieval mechanism is what you are trying to have some in case of precision recall and all, if you recollect, it is there for supervised or unsupervised.
It is for supervised.
Exactly. So why I'm asking that is you need to have your golden data set to prepare this kind of reference. Otherwise, what will happen? It is generating something. I may be able to validate, go to the SME there and then validate. That is only one part of the thing. So if you are able to get, okay, for this kind of golden data set, what does that mean is this is the question, this is the answer I'm expecting. This is the question, this is the answer, right? So if you are going to that, what it really means is there is a reference value for this particular precision and recall for that particular context. So we want to compare against the reference and able to prepare this. That's where the retrieval part is. If you're able to retrieve correctly, then I can blame whether you are rightly giving the information in terms of let's say the generation. So the generation means what? You are trying to give you the retrieval part and even extra information of what you are giving there. The overall context is going there for your answer. Then here also, how factually accurate the generated answer, on what basis it can get, right? Within the LLM also, it has some scores, which as I mentioned to you earlier, it can also give you some kind of a score like 0.7, 0.8 and all that. But usually we will not trust directly. That will be an initial input. On top of it, maybe some kind of a retrieval thing or any of this specific relevancy. Okay, so these points which can do by itself, but I'm not saying that is perfect. Then you need to go further in terms of the testing where you want to prepare again against some kind of reference values, how these scores are changing, and then how these scores are improving over time. So that's what the Raga score for retrieval and generation. Does it answer your point? Whoever is asking. I think Niyaz.
Got it.
Yeah.
Got it. So you are saying ground truth is mandatory for this, right?
This is one mandatory, but I can't say that is mandatory. The reason is we do have some reference. These are like reference-based mechanisms. But I'll give you, I don't know whether that has slide because you are asking explicitly, let me pull that. There is a reference pre kind of evaluation as well. Even in fact, in my evaluation, I can't I can't reveal too much of IP information from the organization, but I also pushed a lot my team to by giving some reference free evaluations as well. There are some techniques which you can try it. I'll try to pull where that information and then try to add the slide. But to answer your point, it is good to have this golden data set, but that's not the only option. There are some reference-free methods also to check.
Now, to contain the expenses, the LLMs themselves are being trained in a kind of a self-supervised or semi-supervised method. Is it correct?
Correct. That's true.
So now, the being that the case, now for the score estimation, if we are requiring a ground truth, that would be a kind of a disconnect, right, Professor?
No, you are not trying to self-sufficient means LLM. You are not evaluating only the LLM thing, right? Even if you are evaluating, you are not here to update their weights and all that. That's not the way. But for your purpose, yeah, are you giving the right context? What else you can do without changing the weights? You can give a little more context to get the right information. That's what is in your control.
So the ground truth may not be like what I'm expecting. It could be like what it could be about.
Yeah, it is more like if I'm giving, forget about the LLM is doing or something else is doing. If I'm giving this question, okay, this is the answer I need to get. right? And similarly, these are the chunks which you are talking about, right? That kind of information also, it's the relevance point of it. That means what? How the ground truth will look like. I still remember my experts, SME experts, are spending couple of days to prepare for this question. This is the answer I'm expecting. For this question, there may be multiple answers as well, right? This is the set of answers. These are all going into the internal ground truth for the evaluation, I can say evaluation framework, right? What I'm talking about is Ragas is one portion of it. Sometimes you need to add, edit further to get the complete picture. That evaluation framework itself is what we are trying to talk about.
So there is a lot of scope for localized engineering on these engines and rack systems.
Lot of
scope for localized engineering, which means that if I am creating a rack system for my enterprise, I can differentiate using such kind of elements. And so, though I may be using a foundational LLM, I have the feasibility to differentiate through such methodologies. Is it correct?
I didn't get fully what you're saying. Such methodologies
For example,
means what?
In the Raga score, right, you say that like there are different methods what can be developed to ensure that whether the response is relevant or not. Now, then based upon the RAG score, if it is absolutely or it is very closely scoring it, then naturally the overall system will go on a iterative mode to make the score better, like something similar to the GAN. So how my scoring is, that level of betterment can be expected from the overall system, right? So I'm saying like this is a place where the performance can be engineered to differentiate when compared to the competitor. I'm just thinking that way and just trying to understand that whether I'm thinking the right lines or not.
Yeah, I think you are in that right line. Let me just share it. I am looking for one slide. I don't not get directly that one, but one more I got. So hopefully, yeah, this may help you out to answer some of your points. Let me see. We are here, right? This. Can you see here? Reference-based, reference-free metrics. So this is not exactly limited to only the rack base, because you are asking here. I thought I'll give you a bigger picture for the benefit of others as well. So this slide is important in it might be sourced from multiple sources, but the point is you do have, just like reference based, you do have reference free mechanisms as well, right? So reference based means wherever there is a ground truth, then you can think of. Otherwise, also, can you see LLM as a judge? I am just like you are talking about. The same LLM thinking is one direction where we need some kind of reference ground truth. Otherwise, also you can have some kind of LLM as a judge, and then go into the semantic similarity mode. Then how the pre-trained model for sentiment ML itself can try to score. Then how the regular expressions can help you. So like that, we do have different scores both for reference based and reference free metrics as well. Okay. On top of it, even LLM based metrics like reason and then score, GVAL, some of them you might have heard of. Then finally, heuristics are rule-based. You have some string checks as well. So from a traditional NLP to the rise of LLMs, we are talking initially it is more like reference-based metrics, right? Some of them, if you heard of BLUE, bilingual language understanding kind of a thing, ROGUE score, KL divergence, JS divergence. These are the things which we have traditional way. Then we do have something like the similarity, then BERT score from embedding based. When you have some of these reference-based metrics, you do have a lot of these rogue supports or some of these changes. Then even some of the LLM metrics are also possible. So what I've just shown you is overall for the RAG, but this one I'm trying to give you a bigger picture in terms of evaluation strategy, where it can be reference-based, then reference-free, and how do you really use that.
Thanks, Professor. And
Okay.
I do not see the perplexity score anywhere here.
That also there is not a complete, but even you can use some of those as well. But only whether it is a really a standard one as a reference one is what we need to see, because this is also prepared based on some information which is available. But you can, it's not like a exhaust list we can add to that.
Okay, just want to understand that the perplexity is no more the metric of LLMs.
No, it is there. It is there as a score. All right.
Right.
So yeah.
Thanks, Professor.
Yeah. Sam. If you are speaking, I cannot hear you, Sam. Your hand is up.
Okay. Can you hear me?
Now I can hear. Yeah, please.
Oh,
Go ahead.
sorry. Yeah, as enterprise AI systems continue to evolve,
Mhm.
do you think the greatest gains will come from larger LLMs or from better orchestration, such as improved retrieval, augmented generation, context engineering, and agent workflows around these LLMs?
I think I'm going for your second option, not the only LLM point of view from enterprise AI. So we have enough of those. Might not have trained on the specific information what we have. That anyway it can never have, because under the firewall you are not allowed to steal the data and then train it, right? So that's one part. So that's where you will your second option will be the default one for me.
Right. This is most of where the developments are going or the applications are going, I can assume.
Yes.
Okay, thank you.
Yeah. You, Simon, you have a question?
Yeah, Professor, just a quick one. So, given there are many metrics, leaderboards, or even to measure the intelligence of LLMs, so is there any leaderboard or common metrics like you show in this slide to measure the RAGs, which one is more intelligent, or the most common RAGs now is evolving?
What do you mean by most common RAG? Are you talking about the patterns, or it's not like a separate model? RAG is like a technique, right? So when you say
Yes, yes, kind of like maybe some vendors embedding model is more intelligence for semantic extraction or retrieval during the index phrases, so that they can rank top of the leaderboard. Just an example. Yeah.
Yeah, that works. That point is, but you understand fully in terms of what is a RAG, right? It's a kind of a technique, and then how are we taking care of this indexing thing, and then how are we retrieving the chunks, and then augmenting it and generating it. The overall flow should be clear to you.
Oh, got it. Thank you. Okay, understood.
Got it. So that brings to last few minutes. We will be, yeah, I'll just close in next few minutes. So this is anyway target for next session, but in the interest of time, I want to see here also, so that I can squeeze in some time and we have enough topics to cover as well. That will also be helpful. So here, where are we going to end this with this particular slide? I can start with this slide itself to on the next session a week later. But let's understand a bigger picture. So right now, so what we will be able to go into the details of it is there are different architectures I'll give you like this in the upcoming slides as well. But the main important thing is in terms of getting a view, which is nothing but your flow, right? At what level you are trying to. So now we have front end back. I'll explain if you are able to see for a few minutes. I'll try to see. This is where okay, let me highlight that in a laser pointer. So if you see here, there is a user, And then from front end, yes, there is an interface like chatbot and all, and where you can see this is a kind of a structure where what application we are using, what kind of package will help you in that, the tool that is also there. So users can interact for multiple things here. So one user is the blue line is what you are asking, and green line is what you are getting. If user is asking some kind of information, it will go down, and then try to see in your app the chatbot, and it goes down. Or if it is a playground, you recollected there may be a playground. That means for you to play in the organization without maybe that depends on how much of flexibility you have in that particular playground. Sometimes it may not be your own information, just like your TensorFlow playground, even OpenAI, Open ChatGPT playground, right? So there are things which are specifically defined, and then you will get an answer. Otherwise, some prompting tools you require, you will reply, you will ask, and you will get a reply. Once you have that, then using chatbot, you are trying to push it to the orchestration. That means LangChain, Llama Index, like that. So once that orchestration is there, then maybe if the data is available in LLM cache, it will come and then immediately go back. That's where Redis and SQLite is what you are trying to use. If it is not there from a cache, that's where the cache augmented generation as well. Then it comes back to the LLM APIs and hosting. Open source models will be there, proprietary models will be there, and then you are trying to see the overall cloud providers is able to work on top of this ML infrastructure to solve a specific problem, and then you will retrieve it back as well. So you are getting the answer, and then you are retrieving it back. Within that process, for your LLM ops or monitoring, I am trying to push some of the information to the MLflow or SageMaker. Within that, if you see on this one, we do have a lot of embedding. So for this orchestration, yes, we need this vector database, then Amazon can draw all that open search. Then comes actually these lot of validations and guardrails, NEMO guardrails, then this constitutional chain. Then you do have a lot of plugins which can help you out. This is the flow, what I'm trying to help you out to visualize and see based on your understanding how much you are able to digest. And then open questions I'm able to answer and then take it to the next step. So let me take a pause. Are you getting the bigger picture, or is there anything which is only the transformers that and all that internally the working and all will cover slightly, but otherwise you should be able to understand the end-to-end flow. I want some kind of a flow diagram. I'm not saying like this only. There are 2-3 more other dimensions I'll try to get you here. That is the thing which you are trying to help you out. Okay. Any questions, or is it making sense? End-to-end flow.
Professor, I have a question here.
Yeah.
I understand that there are a lot of factors that determine how much does a RAG system such as this one cost to build as well as maintain.
Yes.
But can you give us some idea what are the main factors that come into play and how much would it cost?
A cost for what specifically?
If we are building a RAG system where we are feeding, let's say I work in tax consulting.
Yes.
So if we are feeding tax court cases, tax memos, government document.
Got it. How because in this case we are trying to use prompt and RAG, not the complete SLM thing, right? SLM thing is going to take a very costly route and then take some of these. But in your case, just to understand the volume of it, is it like hundreds of documents, each having hundreds of pages, or how do you able to give that?
Documents with hundreds of pages. I mean, you can have as many documents as you want. So.
Yes, but the point is, in case of the RAG, it all depends on the because the performance all depends on how much is the scalability aspect, right? So if you have a boundary in terms of while you are choosing your vector database also, whether you have thousands of such documents, getting time for you to think through that needs to be done maybe separately, right? In terms of the estimation, how you are trying to do. But it's not very costly because the database is also not costly. You can use open source of this. But the main point where the cost is from an LLM tokens and all, but only from a retrieval augmented generation, just you need to have some more time in terms of how these things are working. That's where the real crux is. Let me take a pause.
Okay, and if more data comes in, let's say a new court case comes in, new
Yes.
document is released,
Mhm.
can that be automated in a way that it automatically goes to
So
these
it can,
websites?
you need to create that pipeline. So sometimes if you are adding something and pushing it to index is okay, but do we need to every time do a complete reindex? Maybe once in a while. It doesn't require to be there every every time. So every time you can add something, but and add to the indexing. But complete reindex can happen once in a while. It doesn't require to be every day.
So, sorry, just to clarify, when you say that once the indexing has been done, then
Yes.
is it, what I'm hearing is that the indexing work becomes less because the system has learned indexing. Is that fair to say?
Yes, no, system is learned indexing as long as you are not adding any new document. If you add a document, new document, there are two things, right? Are you changing the entire index every time? That's what the graph rag. There is another version of rag which is graph rag. So some of you are saying vectorless and all that, right? There are variations of it. So in case of graph rag, what happens? A small change, if you are seeing a small changes disturbing the entire platform, then that may not be the right choice. Okay. But at the same time, you are talking about the specific data points and then what you are trying to retrieve and then augment those aspects, right? So you don't require to reindex every time, but if you are at a regular intervals, you want to do a complete reindexing, but before that, it can be a local there as well.
Thank you.
Okay. So these things should be able to give you confidence in terms of when you are doing your solution, your assignment is the first starting point. Somebody asked even if they want to go individually and all. So as long as you are getting permission from the program office, I don't have a problem. So that is one I just recollected. So second thing is in terms of the where the real value add, right? So each of you, while you are designing your assignments, both the individual and the group as well, what it is going to help you out is having a clear flow. This is not the only one in terms of ecosystem what you are talking about. In a week from now, I'll be able to show some more. Whichever you like in a style of it, you can follow and then continue. Right? So let me summarize and then before we close, if you have further questions, I'll be happy to answer further, but let me take 1 minute to summarize and then go. So we started talking about the vector databases in the beginning, why it is that, what is the importance of it, then go into the requirement for retrieval augmented generation. Once you are able to get that part, then we highlighted the retrieval part, then augmentation part, then generation. Generation is giving to LLM, and then in the retrieval part, you do have naive RAG, advanced RAG, then modular RAG as well. Then you do talk about retrieve and read, but rewrite, re-rank, some of those also will come into picture. Then comes the augmentation in an iterative or recursive way, adaptive way. That brings to the point where how you are taking the end-to-end flow for this rack system. I reiterated at one point, we are not touching the original weights here from the model. We are just surfacing it out. There are some variations of it in terms of graph rag or some of the other points. Then we will extend that further into cache augmented generation, vectorless and all. But as we speak now, there are enough problems which we are trying to solve. What will happen after 2 years, 3 years? Will there be better mechanisms beyond the RAG? Yeah, why not? So till that time, we do have at least a couple of quarters. We do have enough problems to solve with the RAG. That's where I'll leave you with. And then towards the end, I was reviewing even this ecosystem. Then with an end-to-end example of LangChain, we talk about both prompting and RAG. Both can go hand in hand. Okay. So any further points before we wrap off? Otherwise, I can officially close the session here. Hopefully, we are adding value to your learning journey. Please practice this both RAG and this individual the prompting aspects as well. So that's where we are right now.
Professor, this is Atif. A
Yeah,
gentle,
please.
friendly reminder that I had sent you a LinkedIn note. You asked me to send you one. So if
Yeah,
you can.
I already replied to you, so maybe I'll just give you a slot. So which time zone you are in, by the way?
Anytime tomorrow should work, or Monday.
No, which time zone means you are in which location?
I'm in Canada.
You are
Right
in
now I'm in
Canada, right?
Toronto.
Sorry, right now in?
Toronto.
Toronto.
So
Okay, Canada time zone, right? I'll reply to you specific time tomorrow. Let me check my schedule. Which should not conflict to your this specific. Or easiest way is I can talk immediately after this also. Because you are let me complete this, then we can immediately talk. That may be easy as well. Okay.
Thanks.
Yeah. Okay. Feel free to drop off if you don't have any further questions. If you have any other points, let's discuss here.
So, Professor, the current research is almost directed towards Gen AI, and almost the other machine learning and deep learning aspects are taking a backseat with respect to research evolution.
Not really. So within Gen AI also, you recollect my painting a picture in terms of machine learning is okay. That's a traditional way. But from deep learning to CNN to RNN to LSTM to this encoder decoder to this attention, then transformer. The flow I was talking right in the first session. So that I'm going to talk a little further in our one of the session, maybe the next one only. That will give you understanding of what fundamentals we are using to go into a Gen AI, right? That's where the transformer based. But there are fundamental research, even from Ann Lucan or even from the Google. Can we change that particular transformer way of doing it as well? They are actually proposed something like Transformer 2.0, or even Ann Lucan was talking about some kind of a vector form from a JEDA, JEDA. So those research is also happening, but yet to replace or think through as an alternative for these proven methodologies. If they're able to prove the 2 years from now, 3 years from now, I don't think we are working exactly on the same thing. If I'm teaching that after 2 years, maybe the prompt RAG may be a small portion of it, right? There may be new methods which may come, which may be, you need to be proven, right? Otherwise, there are so many papers, research papers are coming. But unless they solve the real problem, we will not be able to really worry on that, right? To answer your point, yes, there are things fundamentally, it's not just only the LLM, increase the accuracy, reduce this particular maintenance cost or how fast you can. That is one type of research. The other one is fundamentally happening. How do we say, by the way, why do we require prompt and RAG? Because I'm not able to update the weights in an effective way. If I get some mechanism, transformer 2.0, 3.0, just make that as a self loop and then it learns by itself and then give me that. I don't require any of these complex techniques. Possible, right? If it all going there, right? Otherwise, we are talking about all these indirect methods. So because it is becoming costly, this approach, let me think of parameter efficient fine tuning. Let me think of prompting in this. Let me think of these RAG based ones. So these are temporary. Whether it is 2 years temporary or 5 years temporary, we will see till somebody gives the breakthrough.
Many times when there is an intermediate solution found out, like the entire community sits there, right? There without
Exactly, that happens. And even one more research, if you're really thinking of the DeepSeek, almost has done 30-35 papers. Everything, whatever they do, that's also a good innovation what they are doing. So if you want me to give you some references, one is the DeepSeek links, other one is what Transformer 2.4 people are talking about, and then what is this Anne Lucan latest research, what's he's talking about. These are the couple of references for you to think through in terms of what is relevant, what's happening there, and what is relevant for you.
Sure. And Professor, like, you would be getting into the base transformers as well as the vision transformer and voice transformer, such kind of aspects, right?
So I will fundamentally cover the basic base transformers. On top of it, what is the specific ones and all that we can see. But otherwise, my concentration will be to get into up to speed in terms of all this RNN onwards, LSTM. I will briefly touch upon. On top of it, we will concentrate on attention models, then transformer itself, that architecture. So everybody, because that is what the fundamental thing. My expectation for you is you understand that end-to-end flow. What else will change? It's not very far from my expectation. Maybe this year or beginning of next year, there will be alternative learning mechanisms from these traditional approaches. Is what my betting is.
And I had one question on the transformer, just preceding that. So there are certain deep learning layers within the transformer, and which are basically the weights are not frozen or learned when the transformer is instantiated, and the learning itself, it is expected to come from the overall learning of the end-to-end system, right, Professor? Right. So in that, like, in a deep learning wise, how the back propagation happens, like we have an understanding. But when it comes to, like multiple layers of transformers, and there is the intermediate encoding and so on, and how the back propagation occurs across the deep learning blocks of different layers of transformer. So there some clarity required. Like I'm just conveying this. If possible, you can touch upon that.
Have you understand clearly on the BPTT, back propagation through time for the LL1? So then it is not much different from there, but we will try to see once we cover the base part, what else we can try to see here as well.
Sure.
Okay. Great. Yeah. Thank you. So Atif, you want a separate meeting or you want to cover, that's your individual thing, right? You don't want in this meeting. So let's close this and then ping me there. I'll give you a link and we can connect.
Thank you very much, sir. Yeah, we can do it individually.
Yeah. So I'll ping you a meeting link, then you can join there. So before that, anything specific? Are we good? Prince, Peter, Win, Sam, so most of you are still there. So if you're good, yeah. So we have enough information for you to try it in terms of your assignment, or there maybe you add some more aspects from your practical learning in the next 2 lab sessions. Otherwise, see you next Saturday.
Thank you, Professor.
Thank you.